Hello, everybody. We're here with Jim today. Jim, thank you so much for being here and all the effort you put into this presentation. We connected because of a seminar that happened, which was about natural building organized by Quail Springs. And Jim has an amazing an amazing project that's going on in Joshua Tree, where he's going to be building the first stabilized compressed earth block homes around there that he was able to get permitted and everything else. So it's a really amazing achievement. And your life story is also really amazing, Jim. So I'll let you maybe present yourself a little bit first and then take us through the presentation. But thank you so much for being with us.
Okay, thank you, Rohan, very much for having me on and letting this happen. Uh, Good evening, good day, ladies and gentlemen. This following presentation is about compressed earth blocks. I have been producing and consulting and constructing with and promoting compressed earth blocks for a little over 30 years. So I am a believer, and we're here now because of the fires in Los Angeles. That's what has brought Rowan and I together and has sent me to soon to Southern California. So, with no further ado, we'll start here. This first slide is obviously fire. This is taken at the Los Angeles fires, and as probably everybody knows, they were devastating. This second one is also more of the same. Thousands of acres and thousands of houses reduced to ash. And we're presenting compressed earth blocks as an alternative to wood buildings. I refer to them as kindling buildings. It's kind of an insult, but now we see why. We don't want to do that anymore. So this is after the fire shots. This is shots of Los Angeles after the fire. Terrible. More of the same. You can see what's left after the buildings are completely destroyed. The only thing left standing is masonry. So we're hoping that the city of Los Angeles and Los Angeles County will recognize the superiority of a masonry product versus a wood product. Another after the fire shot. You can see the masonry. These are the taglines for my businesses over the past several decades. Earth and construction is the standard of the past, and it is the hope for the future. And it does represent timeless technology. People have been building out of earth for millennia. So we're not doing anything new here. We're really going back to the pick up the best of the past and move forward with some improvements, which I'll demonstrate. Here are some earth blocks from various manufacturers. The three on the left are from Advanced Earth and Construction Technology Machinery. They're headquartered in San Antonio, Texas. I've run their machinery for years. The next one, pretty much in the center with the largest holes, is from Ital Mexicana in Mexico City. The Pietzesi brothers have been making earth block machines in Mexico City since 1973. And they are the machines that I will be bringing to Los Angeles. I have two Ital Mexicana machines heading to the LA area starting in Joshua Tree. The three on the right with the little dimples and the grooves are from the Aurum Press from the Oroville Institute in India. Sapra Maini is a friend of mine. Actually, the manufacturers of all of these machines, the AECT originally from Lawrence Jeter and now from Ryan Runge, the Ital Mexicana from Francesco Pietzesi, who we'll talk about a lot more later, and Sapra Maini, the three on the right, are all good friends of mine, and I've worked with them in various venues around the planet. Um, this is a project in San Antonio, Texas. And it's not the most recent thing I've done, but it was the first one that I did that was inside the city limits of a major U.S. city. So it was the first one that we were up against um, stringent building department requirements. And so before we could build, the department told me, we have to do a fire test. And I was like, really? Uh, these are earth blocks. We can't burn them. They said, yeah, got to do all the tests before you can get the permit. I said, okay, fine, we'll do it. This is that same project finished. So obviously we passed the fire test and we proceeded, but that's on Eisenhower Street in San Antonio.
And
Here is the
Jim,
beginning of the fire
sorry.
test.
Oh, okay. I was just gonna ask you how you passed the fire test, what you had to do. Thanks. Sorry.
Yeah, well,
I
here
went
it
ahead of
is.
myself.
Yeah, here it is. They
Mhm.
have a place where they do this, a big building, and we built this wall. It's actually you can't see the frame. It's actually on rollers, so they can move it elsewhere for other things to happen to it. So first we had to build it. That's step one. There it is. These are 10 by 14 by 3.5 stabilized compressed earth blocks. They're stabilized with 6% Portland cement, and the mortar joints are a ½ inch. So that's our standard. If we're going to do a 10-inch thick wall, that's the standard wall that we build. This is the fire test underway, and I should have looked up how many degrees this is, but they blast it. I mean, it destroys pretty much everything that's ever been tested. They're typically testing, certain kinds of walls. You have to pass a 2-hour fire rating or a 3-hour fire rating or whatever before your new fancy sheetrock disintegrates. They could have done this to this wall for 10 years and nothing's going to happen. And then when they get done, you know, subjecting it to this massive heat, then the next thing they do is when it cools down, well, this is a fire hose. Then they blast it with a fire hose to make sure that after being burned, it doesn't come apart. Something could theoretically withstand fire, but then when the firemen get there, it just blows the thing apart. I used to be a volunteer fireman, so I know that the pressure coming out of that bale is pretty significant. But they blasted this one, and this is how it looked after the fire and after the fire hose. I managed to retrieve one of the blocks from the fire test, and there it is. So what happens is it fires the brick. It's like a fired brick, but as you can see, it fired the brick in for about 3/8 of an inch. The rest of the block is completely unaffected. The back of that wall, I had my hand on it when they were doing the fire test. It didn't get warm.
Mm.
So when we say fireproof, we're not we're not kidding. We're not fire resistant. We're fireproof. And
Mhm.
this is the proof's in the pudding. And here's the pudding.
And it's interesting too because the redness that you see there basically looks like a fired brick, right?
It is a fired
Yeah,
brick.
it's just
It's
become
made, fired bricks are made out of clay,
right,
and so are we. So it is a fired brick.
right,
But when it's 10 inches thick, I mean, you'd have a hard time firing this thing in a kiln and making a fired brick out of it. And
right.
we don't use fired bricks because you have to burn them. We want to be environmentally correct and not consume. We don't want to burn anything, you know.
Mhm.
Fire. I live part-time in Mexico, and out on the Campo, every mom and pop out there has a kiln, and they're burning bricks. And their kids don't go to school because they're out on the highway picking up plastic bottles and old tires and any trash they can get to burn in those kilns. And it creates an incredible, air quality issue.
Mhm.
Besides the, societal issues of, they're spending all their time burning this trash, and the kids don't go to school, and they make pesos. They just
Mm.
it's awful. It's even worse in India. I mean, India is just consumed with people working for next to nothing to fire bricks. It's terrible. It's terrible.
I think that's a really good point. I heard somewhere that the cinder blocks actually use less energy than a fired earthen brick to
Probably.
make in
Yeah.
general. And your point about the air pollution is very important too. And then I think
Unbelievable.
I don't know if we can maybe mention it, but it also the brick itself is going to lose certain properties like breathability, regulating humidity, and so on. Correct?
Correct. When you fire it, you ruin it, really.
Hmm.
Clay is you're way ahead of me here, Roland. The clay is a breathable product, which we're going to go into later
Oh yeah.
about the multiple benefits of that. We're going to believe me, we're going
Okay.
to see some machines, we're going to see some benefits, we're going to see some houses.
I'll try to
I'll
hold
see.
on to my questions.
No, don't. I like the questions. I'll answer them to the best of my ability, and it's pretty good because I have been answering them for 30 years, and I've had. You'll also see some of my mentors and teachers as we go through this, and I've had um, the kings really, some beautiful men that sent me on the right path. Um, so, right after that, I had another client in Bastrop, Texas, whose house burned to the ground. I went out to see her. I was sitting on her slab, was the all she had left, and looking at the charred remains of her car, her appliances. This was a terrible fire. I didn't see the remnants of her appliances because they were just simply uh, pooled metal, just melted metal. It was a pine forest, a huge pine forest, and it burned severely. So I was giving her all the pros and cons of. I started in with this is why you need to do earth blocks, and she stopped me and she said, "Jim, does it burn?" And I said, "No, no, it doesn't." Then that's what I want. And so this is what we did. This is the house on the left, in process, and that's it, finished. And unbelievably, this was back in 2013, I think. And just a couple of years later, they had another forest fire in Bastrop, and it burned, her. The pine forest was not built right back up to her house at that point, but the brush did burn very close to her building. But of course, she was unaffected. This is another after the fire building in Gale, Texas. This one was more recent. This was 2020, 2021, something like that. And these people called me and came to see me. And they didn't lose the house in a forest fire. They had an appliance fire that burned down their whole house, just ash left. So they wanted to know. They were also shopping for fireproof, and Will and Will and Michelle. And this is in Gale, Texas. Kind of funny story about this. I asked them, like you always ask a client, well, what's your neighborhood like? Are you in a subdivision? Are you in the city? Are you, what's the situation? And Michelle said, we're in the middle of a 6,000-acre ranch. I went, oh, okay. I guess we're not too concerned about the neighbors. No. So it was beautiful. It's out in the desert, West Texas. I mean, it's west of Lubbock, but there's some real beauty. When we were out there early in the morning, birds are chirping and the cactus is blooming, and the desert has its own beauty. But it's a great house, and they're real happy.
And
Now I'm going to
Jim,
talk about some of. Go ahead,
sorry,
Ron.
I'm just wondering, after the first fire test that you didn't really have any issues permitting the other buildings after that.
No, but no, but we might, in California. I mean, if I leave the
Mm-hmm.
state, that was in Texas, and we've been fine in Texas.
Mm-hmm.
Uh, but when we And I have built in New Mexico and Colorado and Montana and Minnesota. I can't count them all, but 8 states and 9 countries. But I've never had to take a fire test except in, and that was because I was inside the city limits of a big U.S. city.
Ah, okay.
When we're out in the Tules, they don't care as much, I guess. But
Right.
anyway, I'm I'm prepared. If we have to, I'm prepared. Other than they're real expensive.
I was going to ask you that. How much did it cost for the test?
I don't recall. It was,
Okay.
that was
Do you have like a range, more or less?
thousands and thousands of dollars.
Like in the tens of
Okay.
thousands?
No, I think
Just under.
10,000.
You
I'm
said,
guessing. I don't remember.
yeah.
And I didn't have to pay it. That's why I don't remember. The,
Okay.
uh, the, the developer and contractor had to pay it. So,
But
um,
that for an individual person who wants to build a house and has to be part of the process would be a huge amount to have to pay.
that's right. So,
Yeah.
it's important to get that done. And
Hmm.
hopefully, the fact that we've done this already in San Antonio will, uh, we've never had to do it again anywhere else. And hopefully, when we get to California, I've got all the records of what they did and how long they did it and how many degrees
Right.
it was. Hopefully, we can say, hey,
Hmm.
look, you know. So I'm going to run through a few more benefits of earth blocks. And soundproof is one. This slide, it's not actually soundproof, but it's real quiet in there, much more so than a stick house. And we had some tests on that, actually, which we'll get to here. The man, this is one of my mentors, one of my heroes on the left. That's Charles Graham. He was the dean of architecture at the University of Oklahoma. He's now deceased, sadly. I miss him every day. But he visited me when I was making earth blocks in Baja California, Sur, Mexico, and he was blown away by it. He bought a machine for the university. I don't know if he bought it. The university bought a machine, and OU started doing a lot of experimenting with earth blocks. And then they combined with the architecture department combined with Habitat for Humanity in Norman, and they built two houses, exactly the same, side by side, exactly the same in every way, except that one of them had earth block walls, and the other one was traditional stick frame, pink insulation, sheetrock, the usual standard American system. So this is the earth block one going up, and then the lower picture is Charles actually inside when we were building the building. He was this wonderful man. So these are the two buildings finished. The earth block one is on the left, the stick one is on the right. And then they were going to do a whole bunch of tests on them to get comparisons. Unfortunately, before they got through all the tests, Charles died. And the new dean of architecture, one of the professors, I was talking to him after Charles died, and I said, well, how's the new guy? And he said, concrete and steel, Jim. Shit. So, excuse me. But, we had a real friend there and a testing lab at OU that was doing a lot of good stuff for us. And then we lost Charles. But anyway, the two tests they did on these two houses, they had data loggers inside and they tested for energy use. And they did it throughout one boiling Oklahoma summer. And the earth block building used 47% less kilowatts to stay cool than the stick building. And then there's Dan Butko, a professor there, was an engineer that tested the sound. He set this stuff up outside and just blasted the sound of the building, had all these microphones and meters and everything inside, and it was more than twice as quiet in the earth block house than the stick house. So better energy, quieter. Bugs. There's only one slide on this, and that's it. The bugs, there's no termites in an earth block house, period. You're going to get the impression that I'm not too fond of wood as a building material. Um, And maybe you've already received that, but this is one of the reasons right here. Uh, no termites, no termites in an earth blockhouse. Bulletproof. They, in fact, are bulletproof. There's kind of a funny story on that with back when uh, Lawrence Jeter still owned AECT. This was way back in the, I don't know what year it was, but we were fighting the Iraq War at the time. And a general and a bunch of bird colonels came out from Washington, D.C. to see Lawrence and at the AECT factory in San Antonio. And they came out, they said, hey, we heard these things are bulletproof. Is that really true? And so they built a little wall out in back of his factory, and they unloaded quite a bit of armor. And they were firing away at it all the way up to 30 caliber machine guns, you know. Pow, 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 pow. Bulletproof. And this is, pardon my language, but this is a quote. And the general turned to Lawrence and he said, why did I have to come all the way out here to bumfuck Texas to find this out? And so I went back to Washington and the Army started buying block machines. And they were special block machines. They had helicopter hooks and Humvee tires and all this kind of stuff. And I thought they would send them to Afghanistan and Iraq and build houses for the people, and then they wouldn't need to, they could beat the Taliban that way. But that's not what they did. This is kind of a sad story. It's a David and Goliath story. They took the machines to army bases around the U.S. and built little buildings so that they could figure out how to shoot through them or blow them up. Because both in Afghanistan and Iraq, the enemy was living in earthen houses.
Right.
And they were hard to shoot through. So they wanted to build models so they could figure out how to blow them up.
What a different paradigm that is. Yeah.
Yeah, yeah. And here's this is the house I built in Pagosa Springs. Bob and Bonnie were both NRA instructors, and so they were real happy about the bulletproof stuff. And this is Bonnie. They had quite an arsenal too. They pulled up their pickup and they had all kinds of guns in the back, and that was the most powerful one they had. It was a 30-30 rifle, and that's Bonnie firing away. She was too good a shot. The the bullet holes were pretty close together in the wall. But anyway, all the pistol bullets flattened out and fell to the ground.
Hmm.
But the 30-30 went in about 3 inches. You can see the hand down there with the stick on it. That was
Okay.
pushed into the wall and to get to the bullet, but nothing went through. It is bulletproof. That seems like kind of a well, so what? Except that the thing about it is it's about hurricanes. If you take a wall or a system or a building, something you want to know about hurricanes and tornadoes, you can take your system up to Texas Tech in Lubbock, and they have a testing facility for that. And what they do is that when they're testing for damage from tornadoes, um, the damage is typically caused by buildings coming apart and the debris flying through the air at 100 miles an hour and striking something. Okay, so what they do is they shoot. They've got a gizmo, a cannon that shoots a 2x4 lengthwise at your test wall at 150 miles an hour. See what happens. Well, you can imagine if that 2x4, I don't know, it go right through siding and the sheetrock and end up in your living room.
Mhm.
But if it hits the earth block wall, it just bounces off. So again, we are tornado and hurricane highly resistant. I don't want to say proof, but highly resistant. And here's a good example of that. I was working in Baja California Sur on a giant project down there, the Loreto Bay project. And this was Mexico. It's a seismic zone, it's a hurricane zone, it's a everything zone. And so the engineers designed the building, as you can see on the right. We built these panels, and they had horizontal reinforcement every 5 I think it was 4 or 5 courses. I think it was 4 courses. And then that horizontal reinforcement would tie to the vertical rebar, a four bar cage that was already in these slots that you can see. And then they would pour concrete in there. And so you'd have a concrete castillo, it was a castle, beam, post, castillo in Mexico. And that's what was really the structural support. They didn't trust the earth blocks at all. However, my partner Jeff and I were in Mexico City when Hurricane John hit the peninsula. It was 100-mile-an-hour winds and 30 inches of rain for 3 days. And Jeff and I were in Mexico City going, oh, I wonder what happened, man. Because we had a bunch of buildings that the walls were in the situation that you see right there. The concrete had not been poured yet. Those are freestanding panels of earth blocks. And so we were quite concerned about how it would be. So after 3 days, we were able to fly back. 3 days after the hurricane was over, because the hurricane had washed out the airport in Laredo. So they had to get that fixed. Then we flew back. We still couldn't get to the site because the highway to the site was washed out. So we got on a boat and went around and went to the site. And then we took these pictures. And this is 3 days after the hurricane left. And those freestanding panels just stood there and kind of went, is that the best you could do? And there were other interior walls out of cinder blocks that were also not filled yet. I got to give them that caveat. They blew over.
Mm.
But these things are heavy. It's these 10 by 14s weigh 38 pounds. And so that's a heavy wall. It's hard to blow it over. That's
And do
for
you
sure.
have two lots? Is there like one on the inside, one on the outside, or is that just me?
Yeah, yeah, there is.
There
Where
is, okay.
you can see, well, if you look closely at the brick pattern, you
Hmm.
can see long courses and then short courses.
Uh-huh.
They wove back and forth like
I see.
this, you know, and that was part of the resistance as well.
Hmm.
That was a hurricane. This is a tornado, and this is in Arkansas. This was and one of AECT's original machines. They were huge. It's an 8,000-pound machine, and the tornado rolled it across this field in Arkansas. You can see the desolation around it, and you
Hmm.
can see what it did to the machine. I mean, it tumbled it over like a toy.
Oh, wow.
But I've got this red circle around the earth block building that was being built with the blocks from this machine. And it's not a close up, but didn't phase it.
And
So,
and in this case, you didn't have any reinforcement. It was just the blocks.
yeah. So it's anyway, I'm
Hmm.
stressing the benefits of earth blocks here for you.
Yeah.
Okay, here's another benefit, breathable. What does breathable mean? The reason this picture is our demonstration for breathable, because breathable means uh, uh, able to absorb and release water vapor. Water vapor is the same size as air. It's not water. And so it's like your skin. Your skin is absorbing and releasing air and water vapor 24/7. But you can walk out into the rain, you don't fill up with water. Okay. This is the same thing that our walls do. Okay. They take it in and let it out. This is John Maroney, a scientist, now also deceased. I'm old, so a lot of my mentors are gone. Um, and he's doing a workshop in San Antonio. That's me in the background. But he also did these units down on the left-hand corner here were originally 4 individual buildings. He hooked them all together like this later, and it was his house. But they were four test buildings when he started. They were all exactly the same size, exactly the same door and windows, roofs, and all that kind of stuff. He's a scientist, and so he was doing experiments. And so these 4 buildings, 3 of them were earth blocks, one of them unstabilized, one lime stabilized, one cement stabilized, and then the fourth one was a cement block building. and he had data loggers in them for a year. They went through four seasons with those things, and he got, of course, the cement building just fried. This is Del Rio, Texas. It's 115 degrees in the summertime, and so the concrete building was just uninhabitable, really. Um, the earthen buildings, he was surprised that there wasn't a tremendous difference between the unstabilized, the lime stabilized, and the cement stabilized. So, even with the stabilized ones, you're still 94, 95% earth. The stabilizer is a very small percentage. 5% to 8% is kind of our range for lime or cement. And we'll get into that a little bit later. But the big surprise that he got, well, it was a small surprise that there wasn't a huge difference between the three earthen buildings. The big surprise he got was that the coolest moment in the three earth block structures, recall this is Del Rio, 115 degrees. The coolest moment in the three earth block structures was 4:30 in the afternoon. What?
That's when you
Correct.
would expect it to be the hottest. Yeah.
Yeah. Well, the buildings had been absorbing humidity at night when it was cool. It is a desert, so it's cool at night, and they absorb humidity, and so the sun pounding on them during the day evaporated that absorbed humidity. So the buildings were their own evaporative coolers,
Mm.
and they got cooler and cooler until 4:30 in the afternoon.
Where maybe all of the moisture has evaporated at that stage, kind of thing.
Right, but
Mm.
then the sun goes down.
Right, right. Yep.
Yeah, it doesn't mean you don't need an air conditioner, but you're gonna run it a lot less.
Right. And Jim, just a question on that one. Do we see some change in terms of how much humidity can be absorbed with a non-stabilized brick versus a lime stabilized, which I imagine would probably be more or less the same, but cement, does cement change that breathability somehow?
Well, probably.
Hmm.
I can't answer that question for sure. I do know that he was surprised at how little difference there
There
was
was, so maybe
in
not
the
that much.
temperature in those three earthen buildings.
Okay.
So
Okay.
he at one point told me it was virtually immeasurable, and I was
Okay.
like, well, I mean, it's hard for me to believe, but
Hmm.
even me, I'm
Yeah.
a proponent, but yeah, we're not fans of cement, you know, but we use a lot less than
Hmm.
every, that's my claim. So temperature, and that's what we just talked about with Moroni's buildings in Del Rio. But here's a great graphic from Cairo, Egypt. Hassan Fathi is famous in our world, an Egyptian architect that advanced earthen construction in Egypt. He wrote a pretty famous book, again in our world, Architecture for the Poor, because he was pushing earthen construction. Anyway, these are two buildings in Cairo, and one of them is made out of earth, that one on the left, and then a concrete building on the right. The black curve, this is a 24-hour period. The black curve is the same on both graphs because that's the exterior temperature on that day. And the temperature is up the left side of the graph there. The hours are going across on the bottom. And the red arrow or the red line is the interior temperature. I mean, do you want to live in a concrete house or an earthen house? This is, I mean, this is, I don't know. It can't get any more obvious, can it really? I mean,
Hmm.
look at that.
Hmm.
And this is a scientist again at work. So that band across the middle is the human comfort zone. And again, the red arrow is what we're after, red line.
And Jim, just in terms of the thermal mass, when we're comparing the earthen bricks and the cement, we're more or less talking about the same width, same amount of thermal mass. So we're really talking about, as you're saying, the evapotranspiration that is in action here, right?
Correct. It's not just the weight, you know.
Right.
I mean, blocks are heavy, but a filled concrete, CMU wall is as heavy or heavier. I don't know. But, it doesn't have breathability.
That's it.
And
Hmm.
that's the difference. It's that ability it's your skin again. It's the
Hmm.
lady's arm there. It's the ability to absorb and release water vapor. And it's called the flywheel effect. You know, when in a hot day, the sun hits the wall and it's going through that earthen wall. There's a bunch of studies on this by uh, laboratories in New Mexico and what's the one in Kentucky? I've got a whole bunch of information about this transpiration, but let's say it goes in for an inch an hour. The heat.
Hmm.
Okay, so by the time the sun goes down, it's going back out.
Hmm.
It takes a long time for that heat to get through a 10 or 14-inch thick earthen wall.
Right.
And then if you insulate it as well, I mean,
Hmm.
it's really, really great. We talked about humidity. That's what we're talking about here with the transpiration. But there was a really great experiment done on this also in Germany by another mentor, Gernot Minke.
Oh, I know
There he
him.
is.
He's also one of my mentors.
Yeah, he's fabulous. Um, this book, Building with Earth, by him, that's the fourth version. I had the first version, which I guess is worth a lot of money now. It's a hardback, and they don't make it anymore. But anyway, I've been reading his books. He's like the first guy I read back in '94 when I started this business, and then I'm with him here. I got to meet him at an earthen conference in Barachara, Colombia in 2009, and I was I was kind of scared, you know what I mean? I mean, a German professor, engineer, builder. I thought, "Oh, this is going to be rough." He's the nicest guy, you know, just a really, really good guy. We really hit it off. He did exhibit that no holds barred feature. One of the days that was a 3-day conference. On the second day, Um, it was in a big cathedral in Barachara in Colombia, and I was sitting at the end of a pew on the aisle, and he was sitting right across the aisle at the end of his pew. So we were right across the aisle from each other. And a woman got up and she gave a whole presentation trying to use like vegetable matter as a stabilizer. I mean, celery juice or carrot juice or, whatever. I don't know. I can't remember. She'd done a lot of experiments and she had all these charts and blah, blah, blah. I don't think any of it worked. I can't remember. But at any rate, all of her stuff was in volume. You know, it's kilograms of this and kilograms of that. Or I mean, not kilograms, but, volume, gallons or meters or, whatever.
Hmm.
And then she finished, and then there was a chance for the audience to ask questions. It was a huge audience. There were a couple of hundred people there. And so you would raise your hand, and then this guy with a microphone would come around in the audience and hand the microphone so you could ask your question. When she finished, Garanats didn't ask for the microphone. He just stood up and said loud enough for everybody to hear, "If you do your experiments by volume, you can be off by 40%." And he sat down. It was like he shot her right between the eyes. It was like, whoa, you know. The next day, I presented on lime stabilization, and he was sitting in the front row. And I talked about how we were mixing the stuff in Baja, and then I was using lime, and I measured everything by weight. I said, our blocks are 5% lime, and I kind of hesitated and said, by weight. And he looked up at me and gave me a big smile. And I was like, I was just floating. Anyway, good guy. And anybody that wants to know anything about earth instruction, start right here. Get this book and just read that book. I mean, this is it's maestro, you know. Mold. Mold kills. And we've got a lot of people in the United States that have environmental illnesses because their houses are moldy. And if you want to grow mold, if you really want to do that to your house, you build a hollow wall, you know, and you trap the air in there where the mold can grow and never get any circulation. And this is a picture of a hollow wall. So just don't do that, you know.
If you were that inclined and you wanted to cultivate mold.
Right. If you want to cultivate mold and try to kill your clients and stuff, this is the way to go right here. Um, okay, I want to talk to lime about lime because I like lime. Lime is has a lot of benefits over cement and also for human health. But we're going to run through the lime cycle here real quickly. It's in Spanish, but it's easy enough to understand. At the very top is limestone, calcium carbonate, CaCO3. Okay, so we want to get a building product out of that. So they put it in a kiln and they burn it. This chart goes counterclockwise. So go left from the limestone and you see a kiln and they're burning and they're guilty. They're they're taking the calcium carbonate and turning it into calcium oxide. They're burning off the CO2. You see the picture there of the CO2 going into the atmosphere. All right, well, that's not good. But it's not as bad as the cement guys. That's our comparison, because they burn off more CO2. In fact, the production of Portland cement is 8% plus or minus of the CO2 into the atmosphere worldwide.
Mhm.
So it's a nasty, nasty product. But the lime is a little better, even though it's burning off CO2, because it takes less heat to burn the limestone than it does to burn the stones for concrete. So a little less heat going in. All right, then you've got calcium oxide. You've got this, it's called quicklime, the little bags down here. Then in the factory, you see a little spigot over here, they add water and they mix it up and it's dry. And that's the white powder you buy at the lumberyard in the bag. Okay. Um, and that's calcium hydroxide, CaOH2. Okay. Um, and so then you go and you get your bag of white lime, and then you take it over here and you mix it with sand and you mix it with water. On this chart, they've also got little bags of pigment. You can also tint it, but just as far as the plaster is concerned or the mortar, you're mixing the powdered lime with water, mixing it up, and then you mix it pretty wet and it's plaster, or you can mix it with your earth and make lime stabilized earth blocks. So if you have lime stabilized earth blocks and earth and lime plaster, then that goes on the house. And then what happens? That white powder in the bag is a frustrated product. It's angry. It wanted to be limestone, and you burned it and messed with it. So now you expose it to the air, going back to limestone. How does it do it? By absorbing CO2 from the atmosphere. That's how. So over a long period of time, it's a round trip ticket. All right. I don't want to say it's perfect, but that's what makes it environmentally better than cement. Okay.
And Jim, could you just, for the people interested, could you just tell us the difference between hydrated lime and hydraulic lime?
Okay. This is hydrated lime. Hydraulic lime will set up. Yeah, I don't know exactly. Oh, I've forgotten. Natural hydraulic lime. They sell NHL. It's a company. It's French, but they sell it out of Petaluma, California. Um,
Yeah, it's
natural
quite hard to
hydraulic
find in the
lime.
US in California, hydraulic
Yeah,
lime.
well, the thing
Yeah.
about the thing about natural hydraulic lime, I'm not exactly sure why it's hydraulic, but it will set up um, on its own. You mix it with water and boom. You don't have to let it cure as long, you know, and
Hmm.
uh,
Hmm.
and you can use it. They use it in Amsterdam, for dikes. I mean, it loves water.
Yeah.
Instead of water damage, it just gets harder and harder. It's hydraulic.
But if someone gets to use it, be careful because it reacts with the water. It gets very hot. That's something to look out for, yeah.
Yeah, and quickly.
Quickly, yeah.
If you if you try to plaster a house with hydraulic lime and your crew's not big enough, you could have some problems.
Hmm.
I know it's happened. I've made almost all the mistakes you can make, but you know,
Great way to learn.
yeah,
Uh, not
yeah.
always.
It's saying that my dad, I knows everybody. Experience teaches the dear school, but fools learn in no other. But I launched into this earth building with enthusiasm, and I've stuck with it, and I'm glad I did. You know. Anyway, here's lime plaster in the making. This is not hydraulic lime. This is hydrated lime, and we slake it. We put it in a bucket, a trash barrel, and we add water, and we mix it up, and then we put a lid on it, let it sit for a day, and then you go back and you take the lid off the next day, and the water's virtually gone, and the putty is much thicker. Okay, it's called getting your lime fat. We like fat lime because then you do it again, and then you can do it a third day. I don't see much difference. There was a Roman emperor that wouldn't let his masons build with lime that hadn't been slaked for 7 years, but we're not in that mode right now. And it seems to me that it gets about as thick and as fat as it's going to get in 3 days. And then we take that's what you see coming out of the barrel on the left. We combine it with sand, and that can be that. However, we've also had in Mexico, I learned about baba de nopal, which is what you see on the lower right. You take the pincas, the leaves off of prickly pear cactus, chop them up, put them in a barrel, and you can just let them, you can either heat it up, like put the barrel on a fire and heat them quickly and get the juice, or you can just let it sit in the sun. And in 3 days, you'll have this slime. It's just like snot, you know, and uh, and then you have to screen it, so that you don't have all the pieces of cactus and the thorns and all that kind of stuff. But if you mix that baba de nopal, uh, juice of the nopal cactus, in with your plaster, it does three things really. It's gooey and it's sticky, so it kind of helps, bind everything together. Um, but it's also, you're in lime plaster. You want it to cure as slowly as possible. You want to mist it for a few days. You want to keep it shaded if you can. You can't let it go off right away, or it won't be very good.
Mhm.
So you have to cure it, to get it to pay attention to cure it. But the nopal helps because what's happening when that lime plaster goes on the wall and then the sun hits it, of course, it evaporates the water out of the plaster, and the lime hasn't had a chance to set up yet. So that's why you need to keep it misted. But if you've got the nopal in there, it's real gooey. It doesn't evaporate real quickly, so you're keeping your lime moist longer with that nopal in there. So that's the reason. Um,
Excellent. And Hendrik Minke did some experiments as well, and he saw that the water resistance, even using it with an earthen plaster, it increases by 30% or something like that in terms of water resistance as well.
right, right. So yeah,
Hmm.
Hernot did a lot of good experiments, that's for sure. Um, all right, this is the Mission San Javier in Baja California Sur, Mexico. This was Junípero Serra's first one. Um, I lived for a while in Sonoma, and that was the last one, number 27. So first and last. This was the first one. He started south and worked his way north. I kind of joke about the fact that he was divinely inspired because he built most of them right on the San Andreas Fault, you know. Uh, but most of them are still standing too, and that's because he didn't know it. He didn't know he's building on the faults, but he had a seismic resistance system by accident. And he built, his walls were 4 or 5 feet thick. And of course, we can't build that way anymore because we don't have 10,000 Indian slaves like he did. So uh, we can't do that. But that was his deal. Anyway, this, while I was working in Baja from '04 to '06, um, the Mexican government was remodeling this mission, and they were tearing the plaster off, and they didn't know exactly what it was. And somebody told them there's a guy over at Loreto, some gringo that's supposed to know something about lime. Well, that was me. And I'm no expert, but I do know something about it. And so they brought a chunk of this plaster to me and said, "What is this?" And I said, "Well, I don't know, but I'll find out. I'll smuggle it back across the border and take it to the lab and have them crush it up and tell us what's in it." And so I did that. And the one on the left, that's what the lime plaster looked like. Okay, I've got this seashell on here because I found that here in Texas, and it's lime also, and it's petrified. It's a rock.
Mhm.
But anyway, the point of this is the piece of lime plaster that you see on the left, and that's the same lime plaster flipped over on the right, and it was examined by the laboratory, and it was 40% lime and 60% sand. That's it. The year that it was put on was the year the mission was built, 1697. So it's 328 years old now, but at that time that was 10 years ago or something. It was 300 plus years old. Okay. And it's fine. It's hard as rock. So
And Jim, that's quite a high amount of lime. Was it done in several layers, or does it seem like it's just one layer?
I'm not sure. It looks like, I mean, when you look at the edge of that chunk, it looks like I can't see any layer lines on it,
Mm,
but that doesn't mean that it wasn't.
right.
Maybe they just put it on thick.
Mm-hmm.
They harl it on, they throw it on. It's not
Right.
not like a hawk and trowel thing. They throw it against the wall and just keep throwing and throwing and then sort of knock it down, although you can see on the left they weren't considered too much about the finish.
Mhm.
But yeah, it's a high amount of lime. But they in Baja, they I mean they burned lime in these little kilns, and it was pretty crude, but people have been doing it for eons, you
Right.
know, and uh, and it works, and that's why they're
Hmm.
doing it. So there it is. So this is the next. I think this is the next slide. Yeah. So 300 years old on that lime plaster. I mean, I don't need to say much about this building, do I? There's nothing here that's going to last 300 years. And that paint job that they're all working on probably is 20 years old, and they're going to scrape it and do it over again. I don't know. Yeah, it doesn't make sense. It just doesn't
Mm.
make sense.
Hmm.
You know, the reason for this is coming up, and there is a reason why it was done. But now we're going to get into seismic resistance. This is in Haiti, 2009. The earthquake killed 250,000 people in Port-au-Prince, and it was awful. I was working in Haiti in 2009. I just started in Haiti in 2009. I subsequently took, Nora tells me it was 27 trips, but I went in and out of Haiti for several years. But this was just after my first trip there that this happened. And it was the reasons that this building came apart so badly are multiple. One, it was a very severe earthquake and quake, and it was right in Port-au-Prince, the fault. And also, there's no building codes, there's no inspectors. You know, everybody's poor in Haiti, and so none of that exists. And one sack cement concrete looks exactly the same as three sack, right? So if you don't have an inspector, you can save a lot of money by using less cement in your concrete. And the rebar, they don't have any rebar factories in Haiti. The rebar all comes across the Gulf, and it's rusty. It's rusty by the time it gets there. So you have rusty rebar, one sack cement, um, no inspectors, no codes, bad earthquake. This is what you get, you
Mhm.
know. Now, this is key because we're talking about California. And, that's why earth building has been limited in California is because they're so afraid of earthquakes. We can do better. We can do really well, actually. But we need to get to the building departments. And now we have the doors open. I mean, Los Angeles burned down. They can't, I don't think, I mean, I could be wrong, but I don't think they can permit kindling buildings anymore. Can they? I don't know. We'll see. We'll see.
It seems
But
to happen each and every time, but I just hope the pressure is there for that not to stop happening. Yeah.
well, we've got something better now that we can do,
Right.
no doubt about it.
Right.
And that's the whole idea of our push into Southern California right now and bringing that machinery. And I'll talk about that more later. Is we've got something better. We can
Hmm.
do this.
Hmm.
And let's see what happens. And we've got a champion. You probably know Ben Loescher.
A little
Um,
bit.
he's great. He's the one. He's an architect in Los Angeles. Also has a office in Pioneer Town, and he's the head of the code committee that's working on the national and statewide codes for earth and construction. He's a he's a hero. We'll talk more about Ben later. Um, so then I had the good fortune. I had met this guy, Marcial Blondet, at an Earth USA conference. He's a professor at the Universidad Católica in Lima. And we talked a lot about earthquakes. And so I had the good opportunity to visit Colombia, or Peru, rather. Colombia too, but Peru. This is where we are here. And I went to see Marcial, and he turned me over to Gladys. This is Gladys in the picture, who's been running the shake table in Lima for 20 years. They have a full-size shake table, and they've tested all manner of reinforcement. And of course, what they're after is something that the campesinos can afford. They can't afford to buy truckloads of rebar,
Hmm.
and they all build with adobe because it's all they've got. And I was in Mexico City. I can't remember what year, 2004 maybe. Picked up a New York Times and says Adobe kills thousands in Peru. I'm like, no, no, Adobe didn't kill thousands. Bad building killed thousands.
Hmm.
It's not the bricks' fault. It's how they put them up.
Yeah.
So anyway, yeah, Marcial and Gladys have been hard at work and still are in Lima finding an effective system to reinforce adobes, or for me, earth blocks, without spending a kin's ransom. So what we're going to here is a building on the shake table in Lima, and they built a building without reinforcement, and this is the one without reinforcement.
And Jim, how thick are the bricks? Oh yeah, we can't hear the sound. Uh, Jim,
You get the idea.
how thick are the bricks?
These walls, I think, are they 10 inches? I think so. But this
Right.
is without reinforcement. Then
Hmm.
they built exactly the same building again, and they used what they have decided is the best system.
Okay.
And I wish we could get to the California codes with this, but Ben and Anthony are working on a reinforcement system that works for earthen buildings in California. But this is Universidad Católica's solution, and I call it the basket. They've got mesh on the inside and the outside. And as they built the walls, they put through ties through the wall. My friend Fred Webster, now deceased, an engineer from Stanford, was involved in this also, and he helped me in Haiti, and he said, do this 1 foot on center. So that's what you've got here. You've got mesh on both sides of the wall, through tide, 1 foot on center, no rebar. Okay, and here's how. Couldn't knock it down.
And I mean, there's a couple of things I noticed. One is they didn't even plaster it. I would imagine that, being plastered would even help. And then the other thing too, you notice is the sort of bomb beam, the wood at the top is not connected to the adobe.
There is no bond beam.
There is
Those are
no
just
bomb beam.
rafters.
Exactly,
There's
yeah.
no bond beam, and they intentionally plastered one side and not another. I don't know what they did on the other two, but
But
they
yeah, you
wanted to see
would,
how much difference it made.
and it
And
does, right?
the plaster actually helps. This
Right.
was another set of experiments. Obviously it doesn't have any tensile strength itself, but what they decided, the reason it helps is it holds the mesh to the wall,
Mm-hmm.
So, but at any rate, they couldn't knock it down. And
Amazing.
then Fred, who you'll see later, it was involved with Marciel on a shake table in Berkeley. Same two guys, and they tested a whole bunch of little buildings. They tested one, without any reinforcement. They knocked it down, or they started to knock it down. Well, you can't. It's too expensive to build buildings over and over and over. So when it started to come apart, they would stop and they would
Mm.
measure what happened, and then they'd go patch the cracks. Then they put a bond beam on it. Then they'd shake it till it started to come apart, and they'd stop. Then they'd put a roof diaphragm on it, and they would go through all these steps. And the shake table in Berkeley is different than the one in Lima. The one in Lima, as you could see, shakes. The one in Berkeley measures ground acceleration, is my understanding. I wasn't there. But what Fred said is that they run it, wham, and then stop. So that, the building gets this jar when the table stops.
Mm-hmm.
So anyway, they put this thing through all these tests, and then the last day they had put the basket on it. They put mesh on it. And they called in the press. They had the TV stations and newspapers going and said, "We're going to knock it down today. This is the last one. You guys got to watch this." So they had the press there. They couldn't knock it down. They could not knock it down. And Fred said that the building would, the table would go forward with the building on it, and then it would stop. And the building would actually tip and then come back.
Mm.
And they did it over and over and over, and they couldn't knock it down. So, I think that California ought to consider this reinforcement
Yeah.
system, and it's
Because I was
cheaper than rebar.
right, exactly. It's very interesting, Jim, because first of all, this is a plastic mesh, right?
Yeah,
Yeah.
they we did this in Haiti, and we did it with basalt mesh, which is really great stuff. That's a whole nother
Yeah.
discussion.
Yeah.
Um, it's melted rock with a resin on it. It's just
Right.
wonderful, real strong. And but in Peru, they were looking for, again, they were trying to keep it affordable for the
Mm,
campesinos,
right.
and they used, yeah, cheap plastic mesh.
That you could get anyway, yeah. Because the in I was in Chile and they what they did is they reinforced existing adobe homes with it and they would create a mesh out of ropes. So it was a little bit larger than that. But they then just drilled holes through the wall, attached them together and so on, and then just plastered it. And it
Great.
was
It's the
it
same.
wasn't in a lab this way, but it did, go through several really strong earthquakes and no issues whatsoever.
Yeah. Yeah. Well,
Mm.
it's the basket. It works,
Yeah,
you know. So
I'm so glad you shared that. Thanks. Yeah.
handmade in Chile.
Hmm.
Okay, here's we're back in Haiti. Upper left is the school when we got there. Um, and then on the right, upper right, are the other kids in their school uniforms. This is in Delan. It's in the Artibonite Valley. Uh, I don't know how far it is from Port-au-Prince as the crow flies, but it took 4 hours to drive there. Uh, Bad roads, horseback, poling across the river. It was quite the adventure. Um, but we wanted to set up. This is before the first building, the old school. We
Mm.
built 3 buildings there in a school complex. The bottom picture is we had finished the first building, and that's what's behind this crowd. And we came and we are going to start for the second building, and we 3 Saturdays in a row we gathered people to try to get a lot of villagers and residents to help with
Hmm.
the construction. And the first Saturday we had 7 people, and this was the third Saturday, so we got a lot of help. It was great.
And
It
what
was
was your
truly
machinery like? Did you have a hydraulic press or?
for the first building. We built with an Orem press from India.
Okay.
Okay, hand press. There's pictures of that coming up. But um, we built that first one. Then there was the earthquake. Then I was back in Mexico. I was living in Mexico at the time. I was back in Mexico, and I had already met Francesco Piazzesi, one of the Piazzesi brothers that owns Ital Mexicana in Mexico City. So I went to see him in Mexico City, and I was in his office, and we're sitting and talking to him, and I said, Francesco, I'm working in Haiti. And he said, really? He said, I'll give you a machine. I'm like, what? And he said, yeah, I'll give you a hydraulic machine. You don't want to be doing that by hand. I said, oh, that's great, Francesco, but you're never going to get it in there. The earthquake, Port-au-Prince is not a port. It fell down. The ships are lined up back into the Caribbean, you know. He said, I'll get it in. And he did. He got it in on a Mexican Navy ship. I'm not sure. I didn't know they had a Navy, and I don't know how he did it, but he's connected. And they're still making earth blocks with an Ital Mexicana 1200 in Haiti today.
Amazing.
And that was 2010. And so the rest of the other buildings we built with a hydraulic machine, but the
Mm.
first one was. So anyway, here we go to those buildings. This is the Ital Mexicana hydraulic machine. They make 2 models, a 1200 that makes 1 block at a time, which we had in Haiti. But this chamber is the machine I've got in Minnesota. It's a 2400, makes 2 blocks at a time. They're 6 by 12, but it makes solid blocks or holy blocks or U blocks. And of course, the holies and the U's were great in Haiti because of the seismic reinforcement. We ran the vertical reinforcement through the holes, we ran the horizontal reinforcement through the U blocks. And so if you looked at one of our school walls and you had X-ray vision, you'd see this mesh or rebar inside the wall that was also tied to the foundation and tied to the bond beam. And
And
that was
so,
just,
sorry,
hmm?
just to understand, so we're talking about regular rebar
Yeah.
that goes in through the holes. The rebar inside of the holes could potentially move, but that's not
No,
an
no, it,
issue.
it
Oh
can't
no.
because this is Fred Webster at work again. I don't know if you know who he was. He's now deceased, but he was the seismic engineer in California for earthen buildings for 40 years.
Mm.
There's some huge wineries that are made out of adobe. When you see those, that's Fred Webster at work. Um, and again, I had the good fortune of meeting him, and we became friends. He and his wife bought some land from us in Mexico. Uh, I miss him terribly. But when I got this Haiti assignment, that's where I went. I went to Fred and said, hey, you know, I don't have an engineer I can trust in Haiti, and I'm not an engineer. And he said, well, you know, I can't, I'm not registered in Haiti either. I can't stamp the plans, but I'll help you. And so this is what he came up with. And I got some help from Ital Mexicana too, because they're making all these adobes, and Mexico's a seismic zone too. So
Hmm.
they have their systems. So I got help,
So
for
how does it
this.
work exactly? How do the
So
how
it doesn't rattle around in there because you fill those with concrete.
I see.
You've got cement mortar, but as you go with the cement mortar, you also have to pack the mortar around the rebar. Because you're
Mm,
right, if you didn't, it would be a seismic augmenter,
right.
rattling around and breaking the blocks. So you got to fill the holes.
And Jim, just because, as you say, we don't like cement that much, would you be able to do a sort of earthen mortar that's stabilized somehow and put that in there? Do you think that would work?
Yes, yes,
Okay.
absolutely, absolutely.
Hmm.
Saffron in India makes a lot of foundations out of stabilized earth,
Hmm.
and they're rocks. He
Wow.
did one. We did a workshop together here in Texas, and we did a wall, and he did the foundation on stabilized earth, and that was 15 years ago, and it's a rock. I mean, it's not going anywhere.
And what kind
So
of percentage for the foundation? Because over there with the
10
monsoon,
it was
that's
10% cement,
sorry,
10% cement.
10% cement.
Yeah, it was clay, sand, and 10%.
Wow. Because they get the monsoons over there, that's a huge amount of humidity.
Yeah. Oh
Amazing.
yeah, yeah. Hades. I mean, you got it all. You got earthquakes and monsoons, and you know, it's it's hazard prone for sure.
Right.
Our school buildings are just fine. Um, so this is how we went with buildings number 2 and 3, and this is the reinforcement system right here.
Mm,
You can see the verticals coming up through the holes, and on the upper right you see the horizontal through the U's. Then you tie them together, and then you fill the U's with concrete.
mhm,
You see on the lower right. So all of the rebar is encased in concrete.
mhm.
So that's the system right there. This is the delivery system. Aren't they great?
Yeah,
Nora saw the slide and she said they look like runway models. And I said, yeah, everybody's in good shape in Haiti, you know,
right,
because
right,
these people, I mean, they're workers and they're doing something all day, every day.
right.
You won't make it in Haiti if you're lazy.
Hmm.
I loved my crew there. And this is them. I call it the Masonry Orchestra. We trained our Masons, and I wanted to take them all to the United States, but that's real difficult now.
Mm, hmm.
Um, but yeah, that's my crew. The guy over here on the far left with the bent over the stocking cap, that's Bachi. That was my foreman. He was fabulous. And they made the blocks, stacked the blocks. I taught them how, story poles, strings. Those walls were perfectly plumb, perfectly straight. Wonderful. Just wonderful.
Mm.
There's the kids going to school in the first building that was done, and that's the second building going up on the right. It's a wonderful project. The sponsor of the project was an organization in Pittsburgh called Partners in Progress, and the executive director is a guy named Mike Newman, and he's my best friend on the planet, and that's how I ended up being there.
Mm.
Where he's also working at Indigenous Peoples Task Force in Minnesota. Minneapolis has the greatest percentage of American Indians of any city in the United States. And so we made 10,000 blocks up there last October for a cultural center for the Indigenous Americans in Minneapolis. I'll be back there in the spring and we'll put some blocks up. There's a drone shot. 2 buildings were done and we were almost done with the third building. But on the third building, which you can see just the walls are up, we left them on their own. We weren't there. And we just went back to help them put the roof on. And they did a great job, just a great job. It's beautiful. So it does work, You can train them, give them a machine, and they'll build buildings.
And you said that now they're continuing to build with the machine.
That's right.
Mm,
That's right. I haven't been there in quite a while. Haiti's a mess now.
hmm.
It's been in the news. It's terrible. It's
Yeah,
terrible. You can stand at the tip of Florida and hit Haiti with a rock. Not really, but it's that
that
close to
close.
the United States. And what we've let happen down there is a national sin. It's unbelievable, unbelievable. But I don't want to. This is not about politics. It's
Politics.
about earth blocks. Okay, carbon footprint. We want, that's the big deal now, low carbon footprint. And we're pretty low, And here's one of the reasons why. Um, no, there's nothing in our earth blocks that comes from China. You
Hmm.
know, it has not been shipped across the Pacific. It has not been loaded on a truck and, like lumber. They're cutting those logs up in Washington and it goes to the sawmill and they take those 2x6s and load them on a truck and drive it to Illinois. But we typically, local labor, local materials is our environmental byword. So we're using dirt. It's locally available and it's locally available worldwide. Here's a source in Marble Falls, Texas. I used this source for several projects. This was a dynamite source because that was perfect dirt and they were screening it. And we could, we never did it, but old Stan here, the owner, Stan Collier on the left, he said, you can set your machines up right here. And that's what I wanted to do, but my partner didn't. He wanted to truck the dirt to the machine. So that's what he did. But it was wonderful dirt. And it was, dirt varies in cost from a quarry, but this was $7 a ton.
Wow.
That's like 14 cents a block. It's unbelievable.
And
But
Jim, as you say, like it even looks humid there. It looks like you don't even need to add any water and just put it right into the machine.
yeah, no, we did have to add water,
Okay.
but very little. We use very little water. It's
Hmm.
the water content in the soil when we make the block is between 8 and 12%.
Hmm.
So not much. That's another environmental story. We don't use very much water
Hmm.
to make our product. We use soil and sand and a little tiny bit of stabilizer and a little tiny bit of water and a hydraulic press.
That's a good point. You're right. Because adobes require a lot of water.
Yeah, no, with a lot of water and concrete,
Mm-hmm.
but not
Yeah.
in an earth block. No. So when I get that soil, then I take it home to my little personal lab that you're looking at here, and I do a bunch of little home lab tests on it. And this is the equipment to do that. But here's some of the tests. Okay. In front, you see some balls here. Okay. I make a ball. I get the soil bone dry. I measure it in 10% water. I make a ball. I drop it from 6 feet up. It hits the concrete floor. And what happens? If it shatters and comes out in little pieces, you don't have enough clay. If it goes splat, like the one on the right, okay, that's step one. Okay, we have clay. We can proceed with the rest of the tests. Then I do the jar test, which you see behind it, which Gernot Menke ripped asunder as a valid test. And he was right. All the things that he said were wrong with it are true. But it does tell you a couple of things. You see the blue tape on there. That's the level to which I put the dry dirt. And then I put the jar almost full of water. I need a little space at the top because I'm going to shake it until all the soil is in suspension. And then you set it on a shelf for a couple days. And of course, the heaviest items sink first. And so you can see a kind of line at the bottom of sand and gravel. And then what you see above that, the reason that Minky didn't like the test is that that's it's not just clay. It's clay and silt.
Hmm.
So it does not really give you a clay percentage,
Hmm.
but it does tell you something about the percentage of aggregate. And the other thing it tells you, both of these, you can see where the clay silt line is. It's right at the blue tape, which
Hmm.
meant that the clay that's in there is not expansive. If you have very expansive clay, it will swell up above that line where the dry dirt was. So that's really the two things it tells you. It tells you about your aggregate, and it tells you if you're shrinking and swelling. Not much more than that. But and you go over here to the shrink box on the left, and this is a certain dimension. There's a chart that goes with it. It's 2 feet long. Those channels are an inch and a half wide and an inch and a half deep. And you take your different soil samples and you get it moist and you pack it in there as tight as you can, completely full, tight. And then this one takes a while because you have to let it dry for a couple of weeks, really. And the stuff will start to shrink up. And then you take a putty knife, and as you see it shrinking, you keep pushing it together, you know. So you're always pushing it to one end of the shrink box. And then when it's done, it's completely hard. Then you measure that little space at the end. And that tells you a lot about how much clay you've got. For instance, the one on the far left has very little clay. Okay. The one in the center has a lot of clay. And the white one on the right has about the right amount of clay. So, it's just how much does it shrink? Because the sand doesn't shrink, the silt doesn't shrink, gravel doesn't shrink. The only thing that shrinks is clay. So this test really tells you a lot about your clay content. I like it. It's a good one. Then when you've done all that and you really want to spend a little money and go down to the lab, the real lab, the geotech lab, and then you get these tests. You get a particle size distribution test, and that's what this curve is on the top. And what's reading across there is the size of the particles and how much passes a whole stack of sieves. And the top siev's got a 1 inch hole in it. The bottom siev's a 200 sieve. You can't even see through it. The holes are so small. And the only thing that'll pass through those small holes is clay. So you get this curve, which is nice to know when you're making blocks. You know, you don't want, you like this is a good curve right here. You got a little bit of everything. And you can see they wrote down here, clay, 24.8%. Okay. Now, a lot of guys will tell you that that's too much. I think it's just right. Um, Sapram thinks that 20% is the ideal. The guys that dwell Earth think 10%. I'm thinking, what? You know,
Mhm.
10%. I mean, you can make a block with that, but remember, we've got all these other benefits. The breathability, the hydroscopic, blah, blah, blah.
Mhm.
The only thing that's doing that is a clay. So, kind of my theory is you want as much clay as you can get without having too much. What's
Mhm.
too much? Well, if you got too much clay, then the block cracks when it cures. And you don't want that. You want enough sand and particles and, all that kind of stuff. So that you can see a brick that looks like that one out of the fire test. It's going to look like that for a couple thousand years. It's never going to change. It's not going to degrade. If it gets wet, it doesn't care. If it gets hot, it doesn't care. It's good forever. In fact, they've got this stuff now. The archaeologists have got these tools now you can do it on an airplane. I forgot what it's called, and you can shoot down to the ground and you can find stuff that's underground. And they found a city in Egypt, south of Cairo, out in the desert somewhere. It's a huge city that nobody knew was there, and they found it by doing this. I forgot what it's called, but they've got
Like
a
this
device that can.
sonar or something like a type of radar, right? That goes,
Yeah,
yeah.
exactly,
Hmm.
exactly. And they found this huge city, and so the archaeologists are like, "Wow, great!" And they're diggity dig, diggity dig, and the pharaoh that was, or the pharaoh's line of pharaohs from the family that ruled this city, he was real proud of his adobes because it's all made out of adobe, of course. And the pharaoh's name is stamped on every adobe. I mean, there's
Wow.
hundreds of thousands of adobes, and he stamped his name on every one of them. Kind of funny. This is another test. This is the hydrometer test, which is more expensive than the sieve test and the Atterberg test. Let's go back. The Atterberg is here. Atterberg limits, you can barely read it, but it says 22. And this is a really good test. It's it's they have two samples. They're both bone dry. You know, they put them in an oven so there's no humidity whatsoever, and they're exactly the same weight. And then they add water by very minute measured amounts until the sample is plastic. And that's called, and plastic means sticky. It finally gets sticky. I mean, that's the best I can tell it, but of course they have an exact, what that means. So that's the plastic limit. Then they take the other example, the sample that's exactly like it, and they add measured amount of water to it until it's not plastic. When it gets enough water, it just turns to slime and it's not sticky anymore. That's the liquid limit. And then the liquid limit minus the plastic limit is the plasticity index. And this is Dave Troutner was an engineer in Durango, Colorado that I took my blocks to, and we're friends, and he took me up to his office and taught me all this stuff. But this plasticity index this is a great number. I think if you get the Atterberg test, you already know if you can make blocks or not, you know, just with that test.
Because
And this
it'll
one
tell
is,
you about I mean, it tells you about the clay.
and it tells you,
Makes
it doesn't tell you just how much clay you've got. It tells you about how the clay is acting.
is acting.
You know, some clays are real sticky, some are not, you know.
Mm,
And there's different kinds of clay and like stabilizing. If you stabilize the lime, it works with montmorillonite, but it doesn't work with illite. So
mm,
you gotta this is I'm pointing all this out because we experiment before we make blocks. The guys buy a block machine. I can just throw dirt in here and make blocks, and that'll be that. No, it's not that easy.
mm.
It's pretty easy. You just got to pay attention to what you're doing. You
Right.
know, that's the whole
And
idea. So
and Jim, I
you
don't know what you think, but for it to become more mainstream, this is probably exactly what we need. People are going to have to send in their type of soil, and the person is going to say you have to add this much clay or this much sand or this much lime. And
mhm.
then maybe they make that mix, send it in again, approved. Okay, you can make your blocks kind of thing, right?
That's right.
Hmm.
That's right. That's exactly right. But it's not that complicated.
Right.
These tests, you can do the lab tests yourself, and you can virtually know before you go to the geotech lab. You're not, but the reason to do your lab tests first is you don't want to waste money at the geotech lab taking something that doesn't work.
Right.
You can find that out by yourself.
Hmm.
And then when you get something, well, I think this is going to work, then you go to the geotech lab because you want those results. You want to show your client, hey, you know, here's what we did. And then you have those results. And yes, if we're going to be mainstream, it's not that tough. There's
Hmm.
geotech labs everywhere,
Hmm.
and they all do these tests, and they're not that expensive.
Right.
So, you can do the test at home, get something that works, take it there, find out about your clay. And then this is another test. If you want to do lime, then there's a whole test you can do yourself. Is lime going to work? You know? And with this test, you can also find out you can use too little lime and you can use too much lime. If you use too much cement, you just wasted money. If you use too much lime, you wasted money and you can have a negative effect on the block. So you're looking for that sweet spot. And you can do this pH test. This is kind of a long description. I don't know if we have time right now, but there's a whole graph that goes with this. And see these little vials back here?
Hmm.
You fill each of those with a different percentage of lime to your selected soil. You
Hmm.
already have your soil. This one's got 3% lime. This one's got, well, I can read these. This got 5% lime, 7, I can't read them. 7, 9,
It's,
8, 9, all these different percentages of lime in these vials.
uh-huh.
Okay. Then you let them set up so it all settles out and it's still. And then you take your pH meter, that's this little blue stick here, and you put it in that water just above the soil, and you can get a pH reading. Okay. And then you've got a chart where you've got the percentage of lime on the bottom, the pH going up the side, and then you can make this graph, and it's going to go up. The more lime you put in, the higher your pH is going to get
Uh-huh.
to a certain point. The pH of lime is 12.4. You want to get as close to that as you can. So maybe the best you can get at, let's say at 7% lime, your pH was 11.9. And then at 8% lime, it was 11.9. And
Mm,
at 9% lime, it was 11.9. Well, no sense using 8 or 9%. You got your maximum pH at 7%. That's your number.
that's how you determine.
Yeah, that's
Wow.
how you.
Okay. Mm-hmm.
And again, I worked at Calidra, the biggest lime producer in Mexico, in Torreon. We made thousands of blocks for them. And of course, they had they were a lime producer and they had a lab that was unbelievable. And we got to go there and play and learn, you know. And so that's where I learned all about this percentages. Anyway,
Amazing.
so I got this little machine from AECT. It's pretty expensive, but it's pretty slick too. And so when I've got a formula that I think is good, then I do my percentages of stabilizer. Then I make these little mini blocks, and then I let them cure. And then what I'm finding out here is I drop them in a bucket of water and see what happens. Oops, not enough stabilizer. It melted. And I know, a lot of people don't like the stabilizers because it's a manufactured product, but uh, I'm all about not using them where you don't need to, like interior walls or if double wall, you could not stabilize the inside, of course. But my first 3 years in the business, I didn't stabilize, and it was in Colorado, and I took some terrible beatings during construction, you know, thunderstorms and mud falling off the wall. And so
Mm,
when people talk to me about, well, I don't want to stabilize, I think, okay, but, you know, we're fireproof, soundproof, bug-proof, bulletproof. Why would you leave? But they melt, you know. I'm making something that's going to be, this is good for 1,000 years. It really
mm,
is. You know, there's no way this house shouldn't last 1,000 years if you do it right. You know,
mhm.
which when you're talking about the environment and embodied energy and all that, if you build something, you have to tear it down and rebuild it in 7 years. It's not very friendly.
Right.
If you build with this stuff, it's good till forever. I don't know how long a species is going to last, but when people ask me how long these things last, I I say somewhat jokingly, I say, I guarantee him for the first 1,000 years. You come get me in 900 if I'm wrong. Um, anyway, so then, yeah, you do all this work, then you make a real earth block, and there it is. And then you take it to the lab, you get it crushed, you get a PSI, pounds per square inch of force it takes to make this not an earth block anymore. And there's some results of those tests right there. Concrete's 3,000 PSI. These two blocks were 2,794 and 2,800.
Amazing.
And that's 7% cement. Okay.
Cement, not lime.
Not lime, cement.
Mm.
But I
You
did
know,
lime ones in Baja
uh-huh.
and they were 1,800. The New Mexico code is 300 to give you,
An
what
idea.
you need to actually build a wall. And that's the New Mexico code, which I helped write the first model. It's been remodeled several times. And now we've got California engineers and stuff saying, we're going to do better. Yeah, okay, fine. But we've been using this one since 2000, but I lost an argument in the code committee because the code committee had a bunch of machine manufacturers. And so they said, well, the Adobe code is 300. Well, that's because that's about all they can get with a sun-dried mud block.
Mhm.
I'm not knocking Adobe. I mean, I love Adobe. I'm happy that, the houses are made out of Adobe. But that's about all you can get for compressive strength with a mud block. So the machine manufacturers, of course, said, well, that's good enough for us. If it's good enough for them, it's good enough for us. And I was like apoplectic. I said, I cannot make a compressed earth block with that low of strength. I couldn't, I mean, just rudimentally using bad dirt and pounding. I mean, I'm going to get 700 before I'm trying, you know? So I fought and fought and fought, and I lost. And so that code still had the requirement for an earth block is 300. But, you know, anyway, I'm sure
Mm.
the new codes will be better. But there's our target right there.
And
And they
and
make,
that was with 7% cement, you said,
yeah, yeah. And the lime blocks in Mexico, I was getting like 18 and 1900
which is
PSI.
which is huge.
It's huge.
Yeah,
Again, they're forever, and we'll
right.
see a couple of those. I know there. That's a 5% lime block that's been underwater for 2 years in Mexico.
Hmm.
This is what we built Loreto Bay with, was all lime. 5% lime.
Hmm.
And they were rocks. We had perfect clay. Perfect clay.
Mm.
And that's called we call it the bucket block. And we kept it underwater for 2 years and took it out. It was like brand new. It's completely saturated with water, but it doesn't affect its structural integrity.
Hmm.
Stabilized. Good deal.
Yeah.
That's a Laredo Bay building built with those blocks.
Oh, that's beautiful.
Yeah. And of course it's lime plastered. Shabam in Yemen, um, adobes and
And
lime.
Manhattan in the desert.
The Manhattan of the desert. You know it well. Um, yes, indeed. So we're getting into some ancient buildings here. And here's interior plaster. It's clay, sand, lime, straw if you want in the base coat to prevent cracking. It's not critical, but it helps. And then I've got a bucket of. Okay.
So just to know, Jim, what kind of percentage more or less are we talking about in terms of the lime that you're adding for this plaster?
Well, as I mentioned on that pH test, if you do the test, it'll give you the ideal percentage.
Mm.
And again, in Baja, uh, right there, we were only at 5%. I mean, you can't go much lower than that. I mean, you've got to be able to mix that tiny amount of stabilizer completely
Mm.
through your mix.
Right.
So another key feature here is the mix. You can't toss it around for a couple of minutes with a shovel and imagine that you're stabilized all the way through. Now, we mixed in Haiti with shovels.
Mm.
We had a pile of soil and sand and stabilizer, and we knew how much, how many sprinklers of water for that many wheelbarrows. And then we had like six guys with shovels, shovel, 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 just mix, mix, mix. And it worked, And they said, well, how long do we shovel? And the answer to that was until it's all the same color. Then you're there. And Francesco in Mexico. I was down one of his projects in Tabasco, and they had 6 machines out there, and or no, 9 machines, 9 block machines, and 54 guys, 6 guys on each machine, and they only had block machines, and then shovels, shovel, 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 shovels and buckets, shovels and buckets. They
Mm.
did everything that way in Mexico because they've got a lot of labor
Hmm.
and they've got cheap labor
Right.
and they got people that are not afraid to work. You know,
Right.
uh, I won't say it, not on something that's being recorded, but let me just put it mildly. As far as a labor force, I prefer some people with pigment. You know,
Because of
so
their work ethic and how much they're ready to work. Yeah.
that's right. That's right.
Hmm.
Yeah, we're deporting all of them right now, so
Mm.
this might be an issue in Los Angeles. Anyway, back to this. That was interior. Then we're on these slides that are, This was the United Nations Brundtland Report in 1987, trying to talk about sustainability. Is that which meets the needs of the present without compromising the ability of future generations to meet their own needs. That's pretty good, but not good enough.
Hmm.
And you know this. This is a little graph we made. It's got, down here in blue, Rowan, this
Hmm.
is this is your website, I think.
No, that's not mine. Regenerativedesign.org, that's someone else's.
I don't know how that got on there.
Okay.
We didn't get this from them.
Oh, interesting.
It's wild. But anyway, when I was making this PowerPoint for Austin back in 2012 or something, we did this. Business as usual, everybody knows what that is. Then we needed to get more sustainable, and we called it green. Then there were all kinds of products that called themselves green that weren't. You
Hmm.
know,
The famous
styrofoam blocks filled
greenwashing trend.
styrofoam blocks filled with concrete. That's a green block. No,
Right.
it's not. You know. So we had to get away from green. Then we went to sustainable, which is the definition you just saw, which is good. It really is. It's very good. It's not good enough. So then we went to restorative. Okay. And that's good because we're it's not just good enough to build something sustainable. We've damaged the planet so badly that we've got to restore it.
Hmm.
And then that's not good enough. And at the top of this slide, I can see it on my big screen, but not on the little screen, is your word, regenerative. We need to be doing stuff that's making the planet better.
Hmm.
Because we ever since Drake punched that hole in Pennsylvania in 1867 and that blue squirted out, you know, it's like one of those inventions or discoveries. People thought that was great because then they could make oil lamps and they could have oil lamps to read at night instead of candles. Well, this is great. They didn't recognize at the time that that discovery was, the end of the species. It's going to kill us all, you know, oil. And so we got to be careful. And we've been destroying things pretty badly ever since then. And so we really, if we're going to, you and I aren't concerned, we're probably going to live a full life. But if we're really concerned about, great grandchildren or something, uh, things have got to be different, pretty
Hmm.
quick. I mean, this climate change thing, the rate at which the planet is heating up over the last few years is, staggering, really, really scary.
Hmm.
So regenerative design, people can live in a mutually enhancing relationship with the earth. We're doing something to make our planet better. That's what we're after. And I'm not going to solve the climate crisis with my earth blocks, but it's a piece of the solution. You know, it's local labor, it's local material, it's non-toxic. We can build buildings that'll last 1,000 years. So this is helpful, you
Hmm.
know, and I'm hoping that that California will recognize that and we can start doing it there in earnest. It's durable. This is Chichen Itza, 1,000 years. There's the oldest continually occupied buildings in North America, Taos Pueblos, hand-packed mud blocks, mud plaster. Indians are still living in them. They're 1,000 years old. Your stick houses just aren't going to last that long, you know. Dejene Mosque, Mali. This is the largest adobe building by mass in the world. And it's mud plaster. All those logs that are sticking out, I wonder, what are those, vigas or what? They're scaffolding. I've seen another picture of that, and people are standing on those logs and they're replastering with mud, every year or two because they just use mud, no stabilization. And here's what got us to this mess. After World War II, this guy named Levitt was an officer in the U.S. Army in the European theater. And his family was in New York, and they'd always been in the construction business. And he came home after World War II and said to his construction family, "Hey, there's tens of thousands or hundreds of thousands, I don't know, GIs coming home right now. And they've all got the GI Bill and they all want a house. And how fast can we put them up and sell them? Because we got a market. They're coming across the ocean right now. And so they went, well, if we take these little tiny sticks and we put them far, far apart, we can build these things in a heartbeat. And they did. And they built Levittown. And that's it. You're looking at Levittown right now, right there. And they sold like hotcakes. Bingo. They made lots and lots of money. And so it stuck. Every contractor around the whole United States started building little stick houses because they could build them real quick, sell them real quick. And it stuck. It stuck, because the government got involved, giving away the forest to the timber companies, and the timber companies were taking their timber down to the sawmills. The sawmills were giving their lumber to the lumber yards, and the lumber yards were selling it to the customers. And we had the carpenters union and blah, blah, blah. And so it became this huge part of the U.S. economy. And so it stuck. I think my PowerPoint is now advancing itself, which I didn't want it to do. But anyway, that's what happened. And it stuck. And now we got to stop that. No more stick houses. We need the forests, we need the trees, we need to build buildings that last, that don't burn Los Angeles, that don't burn. And you can't do that if you're using wood. Wood is a combustible product. And no more. No mas madera. Okay? Please. Anyway, here's some stuff about energy in the United States. This is old. It's like from 2013, I think.
12, yeah.
But it gives you the idea. You
Mm.
know, half of the energy consumed in the United States is in buildings. Okay. Then we've got 44% of emissions, buildings. Everybody thinks about the factories. Look at industry. It's over here at 21. Think of cars puking on the freeway, 34. Buildings, 44. And you've got operations, transportation. This is before the electric car took off,
Mm.
but it was at 1% in 2013. Industry was at 29 or 25. Buildings, 75% of energy, electricity. So if we want to solve the energy crisis, we need to get after the architects, the engineers, and the contractors. They're the biggest culprits. Everybody can buy an electric car, but it's not going to fix the building section. You know, it's us. And this lovely woman is my wife of 45 years, and she is the reason I got into earth building. That's why I put this picture in here. She's chemically sensitive, very. She's a psychologist. She was working at Kaiser in Santa Rosa, and the hospital decided that they were going to build a new building for the mental health professionals. All the psychiatrists and psychologists are going into the new building. And they built a new building, and she moved in her office in there and got like a lot sicker real fast. It was awful. It was just awful to watch what was happening to her because it was a new building. It had new carpet, new paint, new upholstery, windows that didn't open, new everything, new poison everywhere. And it was going to kill her, I think. And so I was sitting at home in Glen Ellen, Sonoma County, got a Time magazine, two snow-capped peaks on the cover. It says boom time in the Rockies. Well, I had lived in Colorado previously. And so she came home and I said, look at this. Let's go. You need to quit that job. It's killing you. And she's backed me up through this crazy adventure the whole way. And she said, okay. And so we moved to Colorado. And these are two of my mentors. I stuck this in here. Fred Webster, I've mentioned, he helped me on the engineering of the seismic stuff in Haiti, and we were friends. He's now deceased. I miss him terribly. I don't know if you know Joe Tibbetts or not, but he's the Southwest Solar Adobe School in New Mexico, and that's where I took my first earth building class in 1994. I took it from Joe, and we've been friends ever since as well. Wonderful guy. He's the guy that ramrodded the first committee to make the first earthen code in the United States, and that was the New Mexico Earth Builders Code. And we did that in about 2000. We did it for 2 years. Joe and I were the only two guys that saw it, made it to every meeting. But he's a great guy, so I want to give him a shout out there. So anyway, we went to Colorado, and this is what I built. That's Earth Block 1. That was our home. It was wonderful. I loved it. We lived there from 94 till 2009. We were victims of the Bush bankster heist of '08, and we went bankrupt, and I lost my house.
Mm.
So that's another long story, but you don't need to tell it here, but I miss it, and we lost it. That was an interior shot of that house.
Beautiful.
And then I went to Mexico. I was living in Mexico, and then when we went bankrupt, I had to come back over the border. But this is before that. This is during that 10-year period I was building in Colorado. This was the biggest castle I ever built, and that was in Pagosa Springs, Colorado. That's lime plaster, natural hydraulic lime. And these are some interior shots of that house. I was blessed with fabulous subcontractors on that house. The carpenter that did this was incredible.
Timber framing is amazing, yeah.
Pardon?
The timber framing is amazing, yeah.
He cut every one of those pieces at his shop.
Wow.
And then I gave him the dimensions of the dining room, and he went to the shop and built it, and then came back and put it together, and it fit like a glove.
Mm.
He did the same thing. Let's go back real quick. You can see the turret down there with the little witch's cap.
Mm-hmm.
Okay, same thing there. We built the turret. I gave him the dimensions of the circle, and he built all the framing for that turret roof in his shop. And he put it all together at his shop. And then he picked it up and put it on a truck and drove it out there. We had a big crane that picked it off the truck and put it up there. We're all just like, boom, fit perfectly.
Wow.
Unbelievable. Yeah, it was a fun job. Good guy, retina surgeon from Baltimore. That's inside that house also. You can see those are exposed blocks with a little, lime slurry and lime clay slurry plaster on. I mean, down below the first bombing, you can see it's plastered, and then the wife wanted to see blocks in a few places. So,
Mm.
yeah.
And Jim, sorry, these are not you don't have any reinforcement going through it. These are just the blocks. Right.
No, that's right. Colorado is pretty stable, no
Mm,
seismic
hmm.
zone,
Right.
no reinforcement there at all. Just bond beams.
Right.
There's a bond beam between those stories
Okay.
and another one at the top.
Uh-huh.
The rule of thumb is 10 times the wall thickness. So if you're 10 inches thick, you basically got 8-foot walls. You got 100 inches, and you need a bond beam.
Mm.
And then you can go up, and then you have another bond beam at the top. This was interesting. The wife wanted to design this for the bedroom. It's a long story, pretty funny. We finally got sick of sending drawings back and forth because she's always changing it. So we built a model of it out of styrofoam and mailed it to her, and it got lost in the mail. It was like heartbreak. We eventually got it done, and she was happy. Um, but I love Jennifer. She's really great, but she was one of the reasons I tell about why you don't want to be a contractor, because she was in Maryland, and I was building her house in Colorado. And this was back when you had telephones, that would wire to the
Right.
wall. She called me once at 5 in the morning, ding, 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 ding. Pick up the phone. Oh, yeah. Woke me up, pick up the phone. Hi, Jim, it's Jennifer. Hi, Jennifer, how are you? I just don't like that turquoise sink in the basement bathroom. Jennifer, it's 5 in the morning, you know. But anyway, we made her happy eventually. This is another one in Colorado, which is, typical, Southwest adobe style,
Mm.
flat roof, parapet walls, some interior shots of that same thing. All natural plasters inside, same building inside. And here's one here in Willow City, which is just north of Fredericksburg. It's about 10 miles from where I'm sitting right now. And earthen walls and earthen roof was the feature here. And that's in the rough. There's some finished shot inside. All the barrel vaults are earth block. And then we had what we thought was going to be a patio out the right side of this picture, out the back door. And then he changed his mind and said, well, I want to enclose that. And so then we did that, and then he wanted domes on that one. And it's like, well, I'm not going to do domes out of earth blocks. I don't feel competent. But I know a guy, and James Anthony he was a foreman for me in Durango when I first started this work. And then I took him to Mexico, and then he became like the vault and dome maestro of the Western Hemisphere. And so I called Jamie. He lives in Mexico in Morelia. And I called him and I said, hey, I got one for you up here. Can you come up? Yeah, he did. So this is another of the inside of that with the barrel vault, earth block
Beautiful.
barrel vaults.
And Jim, you said these vaults are just earth blocks, so they're not cooked. They're all
No,
Are they reinforced, and how did you waterproof it on top?
well, we had to waterproof it for sure.
Yeah.
When we put it up, we would put mesh on it and then a cement coat, just to protect ourselves while we were going.
Mm,
And then we put an amazing waterproofing cover on the top. It was almost like a liquid plaster. We got it from a guy that I want you to know his Nick's name. His name's Nick Gancarelli. I'll give him a shout out right here. Smarter Building Systems is the name of his company. He's in Rhode Island,
mm,
and he sells all manner of environmentally correct products.
mm.
He's the guy where I get my basalt mesh. He also had this miracle roof coating, and that's what we did.
So the roof coating is natural in a sense. It's not like petrochemical or cement based or
I can't tell you what the formula is for this stuff
uh-huh.
because it's a secret. I
Right, right,
can't.
right, right.
It's pure white. The manufacturer swears it's an R30 just by itself. I find that hard to believe, but anyway,
Mm,
that's what we
mm.
did.
But yeah,
And
beautiful,
then
beautiful home. Thanks for the
yeah,
explanation.
and then the what was going to be the patio and then got encased. Then I had Jamie came up and put these domes on.
Wow.
Those are fired brick,
Right.
and it's
Wow.
a pretty
Yeah,
spectacular house. That's
that
been
is
in a couple of
amazing.
magazines, you know.
Hmm.
Yeah, and that's the guy that built this house the guy that got me to come back up from Mexico to Texas.
Mm,
He said, "You gotta come. I've gone bankrupt. He said, you need to come home, and home for me when I went bankrupt was Colorado and Mexico. And he
mm,
said, you ought to come to Texas. And I'm like, Texas? You know, I mean, I lived in California and Colorado. Texas is it's the enemy, you know, in every way, whether it's the Niners and the Cowboys or, Jerry Brown and George Bush. I mean, whatever it is, it's the enemy. And he said Texas, and I'm like, oh, Carson, I don't know. And he said, well, you gotta come see Fredericksburg. You gotta come see Fredericksburg. And so I did. I came up, and I gotta admit, it's beautiful here. It really is.
and the
It's
and
the
the
old
people.
country west of San Antonio and Austin. You've got access to San Antonio and Austin,
Mm,
but you're out in these hills and trees and flowers, and it's hot in the summer.
mm.
That's for sure. But and the town, Fredericksburg, they spoke German here until 1955, right
Wow.
through World War II. Um, it's a German community, German beer,
Mm,
German food, German everything. So it's a tourist attraction,
mm.
but it's a real nice little town, real nice. And
That was a nice side note of the prejudices that we could have, and then how you change your mind on it.
I've been real happy here,
Nice.
and I'm not necessarily. I've still got long hair, which is not really common here, and politically, I'm a socialist, so I don't really fit, with the politics of Texas. But I just sort of hang with my friends and try to keep my mouth shut.
Oh
Uh,
dear. So you're seen as the socialist, the communist.
I'm not a communist. I'm a socialist.
Right. No, but I'm imagining what you might be called there.
They don't know the difference. That's right.
Right, right.
No,
Yeah.
no, yeah, yeah. I'm still
Uh,
a Bernie fan, and I'm happy to see him out on the road right now. Uh, but anyway, politics. That shouldn't have got in here because this is taped. This is recorded, right? I'm going to put this thing out for years to come. So, this may be cause of my untimely death. I don't know.
no,
Um,
I could get rid of it if you want me to.
yeah, maybe some of these political comments can go. Anyway, Jamie and I have been buddies since we met at the Joe Tibbetts workshop in 1994. And I took him to Loretto, and he became the vault and dome maestro of, I think, of the Western Hemisphere, maybe. He's done some work in Brazil that is unbelievable.
Hmm.
And he's an amazing guy and a good friend. Um, I got a little frustrated with him when he was doing Carson's job because he was staying at the job.
Hmm.
And I had a cot out there, the place was the main house was roofed in, and he could stay there. And he's a guy, he's fond of mezcal. And, and so I'd come out the job and say, Jamie, can't you just like put all these empty mezcal bottles somewhere else? This doesn't look good. And Carson, the client, was just in love with Jamie. And he said, I don't care what he does. These domes were beautiful. So he, he's a great guy, a great guy. And he's not an alcoholic. I don't want to make it sound that way, but he likes mezcal. Okay, here we are back in Baja California Sur, where we had three AECT 3500s, and here we are celebrating our 1 millionth block.
Hmm.
And those were the ones that were all 5% lime stabilized. We built all those beautiful houses. But you can see our bottle of Coralejo tequila there on the block. It was about 10 in the morning, but we were celebrating that millionth block.
Amazing.
It's quite a deal. There's the three block machines in Baja.
Oof.
And if we could make theoretically 9,000 blocks a day, but a lot of times it was one, we had three block machines, a giant mixer, two skid steers. It was usually, one machine down. So we didn't get 9,000 a day every day, but we had that capability.
Hmm.
And then they built houses like this, on the beach in Loreto. This is in San Miguel de Allende, which is currently actually my home. Um, it's the only place where Nora and I own a house is in San Miguel. And that's because we bought a house there in 2006 before the bankruptcy. And
Hmm.
so they took everything it was from us, but they didn't take Mexico. So we were very fortunate to have property in Mexico. But anyway, RISD, Rhode Island School of Design, a famous engineering and architectural school. They come to San Miguel every year, send some architects and engineers, and they design a building and they do something for um, the less fortunate of San Miguel. I know this building doesn't look like it's for the less fortunate, but it is. It's a cultural center in dead center in the poorest neighborhood in San Miguel. And and they used our earth blocks. Those are all um, the name of my company at that time was Instituto Tierra y Cal, Earth and Lime. And we made blocks with an AECT uh, impact 6x12s. So that's what those are. And we were lucky to get that project.
And those ones are reinforced though.
No,
No.
no, no.
Are
It's a
they,
double wall.
they're
It's 12
flat
inch.
on, sorry.
It's a 12-inch wall. They were six
Right.
by
So,
12 blocks, but it's a 12
mm,
inch.
because they don't have any earthquakes over there, or just it's so
They do. They do have them in Mexico. We haven't had any in San Miguel.
okay.
Um, but
But because they're so
did we
big,
have we maybe we did have. Wait a minute. Yeah. I think we did use Holeys there and had vertical reinforcement.
okay.
I can't, this is a long time ago. I forgot,
No, no, fair enough.
but I think we did. I think we did. I'll double check with Jeff. He'll remember. I'll let you know. This is Casita Linda. This was a really wonderful organization. That was the name of this kind of group of do-gooders in San Miguel. And they built a house a month for people that needed them. And this little metal shack was a single mother with, I think it was like 7 children.
Mm,
And that's where they lived. But they found out about our earth blocks and started building their house a month out of earth blocks. And the woman that lived in that shack then got the house on the right,
wow.
which was a Casita Linda earth block house.
Muy linda casita.
Yeah. This is a little 30 meter I built on. I've got some rural land outside of San Miguel, and I built a little 30 meter out there that's now occupied. Um, and we did barrel vault roofs on that with steel trusses. These are I-beams, and then the barrel vaults out of earth blocks.
Mm. So the
And that
I-beams,
building,
how thick are they?
those are 6 by 12s, but it's 2 layers.
Okay.
So it's 12 inches thick.
Mm.
And Etal Mexicana did some studies and tests on the barrel vaults, and they did them with the 6 by 12s standing up, like the ones that you saw in Willow City.
Mm-hmm.
And then they did double layers like this. They're the same thickness and it's the same number of blocks.
Mm.
But they did some tests and determined that this was stronger
Mm.
to have the double layer of flat blocks than one layer of vertical blocks.
Interesting. Yeah, good to know.
Yeah, I didn't either. But that was their result, and that's what we did on this particular building. And that's what we did on this building. And this is in Welfare, Texas. And this lady um, came to one of my workshops in San Antonio, and she drank the Kool-Aid, you know. And what I mean by that is, earthen walls, earthen roof, earthen floor, lime plaster, composting toilet, solar power. I mean, I called this building the whole enchilada because she did it all. And it's pretty incredible, pretty incredible. Here's a finish. This is it. This is it almost finished. But she had earthen walls, earthen roof, lime floor, um, lime plaster on the outside, clay plaster on the inside, composting toilet, solar power, water catchment. I mean, she did everything.
Wow.
You know, it was, it's like your regenerative design for your organization is named what she did, you
Yeah,
know.
right. Exactly. It's a perfect example. And I'm wondering for the earthen roof, how was it made? Was it the same vaults or was it?
It was, yeah, here, let's go back. There they
Oh, yeah,
are.
yeah, yeah.
Yeah. And they were the double layer of flat also. There's a single
On
layer done
top.
here, and then
Right.
there's another layer to go.
That comes on
Okay.
top of it. Yeah.
And in barrel vault roofs, it's easy to catch the water, you know,
Mm.
because you got all these valleys, and then
Yep.
you just go put mortar in the valley and make them slope all at one end. And so every drop of rain that hits that roof is shooting out the valleys on the end of those barrels.
Right.
And so
And
it's easy to catch.
and you waterproofed it with the same material that you were mentioning before.
Yeah.
Yeah.
Yeah. Yeah.
Amazing.
Yeah. It's good.
Hmm.
And I had clay plaster from this was before I knew about American clay, but I knew this guy that was making clay plasters in Denmark, and I got a whole bunch of his. It's called Tierra Fino, and he's got all kinds of colored clay plasters, and that's what we used on the inside.
Mm.
But now you can get American clay. The thing that's different about Tierra Fino and American clay has every color in the rainbow too, but they use pigments to get the different colors. The guy in Denmark has mines all over Europe, and his different colors are actually
Using
different colored
clay.
clay.
Wow.
And he's got yellow and red and white and green and black and, all these different clays. But anyway, clay plaster is a wonderful thing because it breathes like the blocks.
Hmm.
That's why when people say, well, can I paint these things? I just look at them and say, we don't paint. I forbid you to paint. No painting. You can paint pictures to hang on the wall, but no, don't paint, please, please.
Actually, Jim, that's a good point. Have you found people that put like acrylic paints on top of like earthen walls or even like a cement plaster? And what would you say? What are the kinds of issues that you know about or you've
Well,
seen?
they can do it. They can do it. They can put cement plaster on it and paint it, and it'll work, except, paint doesn't last very long, so you're going to have to repaint. But about the environmental thing for the human beings and the planet, the cement doesn't breathe. You got
Mhm.
cement and paint, you've just ended the transpiration of water vapor.
Right,
It's over, you
right.
know. So you can do it and it'll be okay, and if you're married to that technique, go ahead, but
Yeah.
I'll do everything I can to talk you out of it.
Yeah, yeah, yeah. I've
You know,
I've seen what I've seen when I've seen cement plasters over earthen walls is that over time, as you're saying, the moisture kind of gathering inside of the earthen wall, trying to
correct.
make its way to the outside, will condense against the cement, and over time, it'll just move out. It'll just break off in any
It'll
case.
move
Yeah.
out and it'll also, depending on the quality of the earthen wall that's inside it, you'll degrade the wall.
Right, right. Because
You
the
know?
moisture is just getting stuck in there. Yeah,
Yeah, yeah. Humidity can actually be your friend, if you work with it instead of against it,
right. Hmm.
So here's one in Austin. Um, this is a big one. And the client and the contractor, I was looking for dirt, looking for dirt, looking for dirt, and wasn't sure I was going to find some that, would be compatible with lime, and maybe I was going to have to use cement. And I told the contractor, and he just looked at me, he said, Jim, Becky is going to have lime stabilized blocks. Get it? Okay, So I kept looking, and we did it. We found adequate soil and a quarry outside of Austin that would accept the lime, and those are all lime stabilized blocks.
And
And
Jim,
yeah,
just out of curiosity, when you're looking for the soil, what are usually your techniques? Like, where will you go to?
well, the first place to go, I mean, a lot of clients want to build with their own dirt. I want to use my own dirt.
Hmm.
Well, okay. Are you digging a basement? No. Mm, okay. Are you berming into a hill? No. Okay. Are you
You want
making
a
a swimming
swimming
pool?
pool?
No. What are you going to do with that 20 foot by 40 foot by 8 foot deep hole in your ground?
Right.
You know, now on Earth Block One, my house in Colorado, it was unbelievable. I mean, it was my first one, and it tricked me because we did a basement and the dirt was perfect, and the basement pretty much made every block of the house.
Mm.
It was amazing. Out of the ground and up.
Hmm. Hmm.
Never trucked anything anywhere.
Wow.
Um, but that's not typical.
Right.
Um, but you can dig and screen, and make your blocks out of your own soil. You can do that. But when I'm looking for soil, I go to quarries,
Mm.
because they've got quarries are typically they're mining for clay, or not. They're not mining for clay. They're mining for sand or gravel or boulders. stuff they can sell, right?
Hmm. Hmm.
And they usually have these big piles over at the back of the quarry that they call overburden. It's the shit they can't, excuse me, it's the stuff they can't sell. It's
Uh-huh.
clay. It's our stuff.
Right.
It's overburden. It's waste. So that's the place to go. You just
Yeah.
when I get to California, I'm gonna, shop all the quarries I can find and find somebody that's got clay to throw away. And then sometimes they'll screen it for you, which is really nice. But that's the first step in when I want an earth block house, and they say, "What's the first thing I have to do?" I go, "The dirt search."
Hmm.
That's first, you know. And that quarry that we found that I showed you the pictures of in Marble Falls was like that was a dream come true. You know, it was just wonderful. But that's the first place to look. Anyway, okay. All right, here's what we have a pretty large house, a nice house in Austin, Texas. These are all lime stabilized earth blocks. And there we are. We've got some more finished shots of that. There it is finished. This one was another kind of whole enchilada deal. They did rainwater catchment, earth blocks, lime plaster on the exterior, clay plaster on the inside, solar power, water catchment. They didn't do composting toilets. They had regular toilets, but they did a lot of the regenerative stuff. It's a beautiful house. Here's some interior shots, and here's another one. And that's it. Randy and Becky's house. Here's the Esperanza Peace and Justice Center in San Antonio. San Antonio has the distinction of having the largest percentage of its population be Hispanic. There's more Hispanics in Los Angeles, but San Antonio is like 63% Hispanic. And so this organization, Esperanza Peace and Justice Center, is kind of like a hub for the Hispanic community. And they wanted to build a building. They have a lot of women that make artwork on their campus. And so they wanted to build a building for the women to do their artwork, and that's why it's called Mujer Artes. It's the women's art. And because they were Hispanic, they were interested in earthen structures. And they found me, and this is it. These two slides are put together. It makes the building look like it's square, but actually it's a real long, skinny rectangle. Those two pieces you see are not a corner. It's a you just pull them out like this, and then you'll have it. Um, but it's all earth blocks and lime stabilized earth blocks and lime plaster on the outside. It's a beautiful thing, and they're doing all their artwork in there. And just a couple of years ago, they built another building out of earth blocks where they're displaying their art for sale. But it's a very political women's art organization in San Antonio. It's a wonderful thing. So that's that. That's the inside of that building. That's where they're making their art on those tables, and they have all these racks to store their art and artwork. You can see little arches at the end. It was quite the project. This is in Taos, New Mexico, typical New Mexico adobe, but this one's Earthbox. It was a real beauty. This was a little tricky because she was a practitioner of what's the Indian version of feng shui? Um, anyway, it's got another name, but it's the same idea. And so the interior dimensions had to be exact. They were magical numbers. I'm not knocking it. I just don't know about it. But she was really intent that it had to be, you know, 12 feet, 3 and 3/16 inches between these two walls, which is really difficult to do when you're plastering.
Right, 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 right.
So we had some challenges there, but we got it done.
I'm curious, what could it be? It's not like Ayurvedic? No, that wouldn't be it.
No, uh,
Uh,
It's in the practitioners in India mock the Chinese because of their feng shui. They say that was stolen from us, and they ruined it. You
I
know,
see.
we have the real deal, and it's I'll find out and let you know.
Okay, well, yeah, yeah.
I can't remember the name, but it was, all the dimensions had to be magical, and
So you had to plan like your plaster beforehand, how much that was. Yeah. So it
well,
just
if the
complicated work for
plaster is
you.
supposed to be, 9/16 thick, I mean,
Right.
it's plaster. You know,
Yeah.
it's I don't know. We got it. It was all right. She's happy.
Nice.
This is in the backyard of a house in San Antonio that I was living in for a while we built the Eisenhower project, the one you saw first.
Mm, the massive, yeah.
I was renting in this big house in San Antonio, and we had a lot of the crew living there also. And we built this as a workshop project in the backyard. And it's 200 square feet, which was the largest thing you could build without a permit. So that's why we built 200 square feet. But it was actually because of the barrel vault roof, we had a loft
Ah, right.
and you could sleep up there. And so the 200 square foot area didn't have to include a bedroom.
Mm,
And so we had, a great room, which was, the living room, dining room, and then a little kitchen on the side and a little bathroom down there, and that was it. And two people could live there quite comfortably, actually.
mm.
And again, earth blocks, lime stabilized earth blocks, lime plaster, barrel vault roof, blah blah blah.
And your roof, when you build it, do you have like a formwork that you put in and you move along? Or
Yes, exactly,
yeah, okay.
exactly. We make a plywood form,
Uh-huh.
and the bond beam's already poured, so you got this concrete bond beam,
Right.
and then you have to shim the form. You set the form on the bond beam or on the typically it's the form is sitting on the uh, some temporary rails that you bolt into the wall.
Uh-huh.
Okay. And the bond beam form sits on those rails are slightly below the bond beam. And then when you set the form on there, you shim it on both sides. You run shims underneath it so that you can get it out.
Right.
You put all the bricks on it, then you pull the shims, and then it drops down a half an inch or 3/8 of an inch, and then you can
Mhm.
slide it along these rails to the next set.
Mm,
And that's
great.
that's the way it's done.
Amazing.
That's the way I do it. Satpram does everything formless. I mean, the guy's the magician.
Wow.
Satpram Maini, the Oroville Institute.
Yeah.
He's unbelievable. Unbelievable.
Huh.
He's building a dome right now in India. He sends me pictures every day. It's 33 meters in diameter. In diameter. It's, it's over 100 feet across. He's got 90 masons working on it, and it's 4 layers thick.
Mm.
It's unbelievable. I'll send you some pictures.
Oh, that would be amazing. Yeah.
I'm getting WhatsApps from him every day telling me about the progress.
Hmm.
Anyway, this is in Durango. This was hexagon. I can't remember if it was a hexagon or octagon, but I learned a lesson here. Don't do that.
Hmm.
If you want something like that, do round.
Mm.
Round is easy. It's very easy. You have one story pole in the middle. You got an arm that goes out, and you raise it up 4 inches every time. And
Mm.
your courses are perfect. Your walls are plumb. One story pole. It's easy. It's beautiful. It's seismic resistant.
Mm-hmm.
Round is like the best thing you can do.
Mm-hmm.
But a hexagon or an octagon, on my rectangles, my story poles are angle iron.
Mm.
3 by 3 by 3/16 angle iron. Put them up on the corner, get them plumb, pull the strings between them, and bingo. Your
Mm-hmm.
walls are plumb, your walls are straight, everything's hunky dory. Hexagon, octagon, now you got to build your own story poles, 22 and a half degrees or something. And the number of cuts on the blocks is,
Mm,
you're coming into these hexagon or octagon corners. Every block that comes in there has to get cut. And then some of them have to be cut 3 times because you got to cut them back so that your head joints don't overlap. I mean, you're cutting like a maniac.
mm,
And with round, you don't cut at all.
mm.
You never cut,
You
you know.
just fill it in
So
with plaster. Yeah.
yeah. Anyway, it
Wow.
came out well. It turned out it was sort of a selling point because the guy was a musician and he had a podcast and he had a band and it was a sound room for him.
Mm,
And again, the earth block walls were, what he wanted. And it worked in that regard. This is in Sedesa. We're not in Sedesa. It's in Dolores Hidalgo, Mexico. And it was an organization called Sedesa that worked for the campesinos. Was mostly about agriculture and water. But they also had them building houses, but they were building the houses out of fired brick. And so somehow they got in touch with us or we got in touch with them and went, why are you doing that?
mm.
You know? And so we convinced them that they should let us build an example on their land, how to do it better. And this is it. And this was another whole enchilada deal, earthen, earthen walls, earthen roof, earthen floor, water catchment, composting toilets, solar power, the whole, the whole enchilada, you know,
Mhm.
it can be done, it really can. This is, I don't know if you've heard about Rancho La Puerta.
Mm-mm.
It's the oldest spa retreat in the world.
Mm,
And it's in Tecate, Mexico, and it is beautiful. It's a real high-end deal. The lady right in the middle of the crowd there, she's got a blue shirt on,
mhm,
is the is Sarah Brightwood. She's the queen bee, and she wanted to expand the housing, and so I don't remember how she got a hold of me, but she let us do a workshop there and build a sample, and that's what this is the students at the workshop, and that's the sample house.
And they did
They were going to do a lot more,
uh-huh.
and then we finished that house, and COVID hit, and they didn't do anything.
Mm. But it's interesting mixing the top part with I don't know what you would call it, pajareke or
Yeah,
mhm.
Bajareke. That's right. That's
Yeah.
right. Yeah. And they had a loft up there too.
Mm,
That's where there's a window there. The guy that was going to live there worked on the crew, and he was one of the counselors there or something, and he had his bed upstairs. Turned out to be a pretty nice little building,
mhm,
but again, they didn't. I was hoping to build 200 of them for them, and they didn't do it. COVID stopped everything.
mm,
Okay, machinery. Here's the first one. This is the Sinva Ram, and it was invented the in in Bogota in 1956. That's the first earth block machine of the modern era.
mm,
Okay, and that's a sample of it. It's a man eater. It's hard to pull. It makes one block at a time, real slowly, but that's the first one. So it's kind of the grandpappy of all we do. And the first major building or development built with the Sinvaram was a village in the eastern plains of Colombia called Gaviotas. Have you ever heard of it?
I have. They experiment with all kinds of amazing technologies,
Unbelievable,
right?
unbelievable. And so their whole village, their whole development, all their buildings are made out of earth blocks. It was
Wow.
the first major construction project out of earth blocks. This guy on the right is Paolo Lugari. He's one of the engineers. There were a group of engineers in Bogota that talked to each other and said, we recognize the world's problems and the expanding population, the degrading environment, and what's going to be the cure. And they decided that one of the cures that you weren't going to limit population. That wasn't going to happen. And
Mm,
so what you got to do is people are going to have to live in places that we currently call uninhabitable.
mm,
And they were in a plane flying over the Llanos, the plains of eastern Colombia, a desert, some cactus and a few big jackrabbits and snakes, and that's it,
mm.
uninhabitable. And they said, that's it. That's where we got to do it. And what you're looking at behind that picture of Pomona is what it is now.
That is
And they
amazing.
changed the environment. They planted 2,500 hectares of trees,
Right.
and they live in a rainforest. They make their own rain. And then they they reinvented everything. They reinvented windmills. And you know how windmills have the tail coming out the back? They turned the fins the other way and put the tail in front, and they pump water from 3 times as deep as a regular windmill.
Mm,
Unbelievable. Did the
mm-hmm,
same thing with hand pumps for water. It's a sleeve pump. You got a sleeve and you got a cylinder that goes up and down the sleeve.
mm-hmm,
And that's the way these hand pumps are made to get water from the ground. They have a sleeve and they have this piston that goes up and down. They turned it around. They fixed the piston, pulled the sleeve up and down, and get water from 100 feet instead of 20 feet.
mm,
I mean, this all sounds too simple, but that's the kind of stuff they did.
mm.
And they've got this forest of tropical pine trees, and they walked us through the forest, and I got to go there, Rohan. I mean,
Amazing.
it's unbelievable.
Mm.
It's unbelievable.
That's my
Uh,
dream actually to go visit it. I have visited Oroville, which actually is similar in the sense that they took a barren land and started growing trees. And I remember meeting someone who was from there and who said, "I like this place, but it has too many trees."
do
And
you
the
know
guy
that
just laughed at me.
that it's in trouble right now? Did you know that?
No.
They kicked Sapram out of the country, and then they kicked him out because he was raising kind of such a fuss. So they got some new governor of the state that it's in, and she said you're not you don't really have rights to this land, and so they started putting roads through it and knocking down buildings of Oroville.
Whoa.
He sent me a video of this tractor coming and all the Orovillians out in front of it, going, no, no, trying to stop the tractor. But the tractor, the bulldozer, had a gang of goons with it. It just
To
knocked
do
people out of the
that,
way. And
right.
it's unbelievable.
I
It's in
didn't
trouble.
know. I didn't know about that.
It's
Whoa,
awful.
because it's part of UNESCO sort of
It
like
is. It's a
heritage as like
UNESCO
the
site.
the city of the future or something like that. Yeah.
Exactly. Exactly.
Wow.
It's incredible. But anyway,
But yeah, sorry, yeah. Let's come back to
yeah,
Gaviotas.
yeah, but back to Gaviotas. So, um, they um, they have this forest of tropical pines, and they slice them and staple a little plastic baggie underneath the slice, and they slice and they collect the sap,
Hmm.
and they make biodiesel out of it, and that's how they run all their equipment.
Wow.
And they've got a biodiesel factory from this tree sap, and it doesn't hurt the trees. I
Yeah, they're
mean,
not
they've been
killing
there
them.
so long that when I was walking through there, you're looking at the trees and you can see the slices. They go up 8 or 9 feet,
Mm.
but it doesn't hurt the tree. And so then they just keep slicing below it and tacking the bag on it. And they're farming products. They grow all their own food,
Hmm.
and they don't plant anything in rows. Their theory is 250 species per hectare, and that way you don't have to use any fertilizer or insecticide because all the plants take care of each other, and
Right.
you don't need that shit.
Hmm.
You know, unbelievable,
Symbiotic
unbelievable.
farming. Yeah.
From the biodiesel to the food. And then with their pumps and their water they're getting is so pure, they're bottling the water and selling it in Bogota and making money.
The what water? The rainwater, the water from the wells.
No, it's water from the wells.
Wells, yeah.
And
Mm.
I mean, on and on. I flew in there. I got to go there. A lot of this is going to have to be cut out of your presentation because you and I are just having a conversation, you know. But I I had read the book Gaviotas, Ability to Reinvent the World.
That's the one I read too. That's where I got the yeah.
A professor in University of Arizona or something wrote.
Right.
I didn't like the book that much. I didn't think he was a very good writer,
That's me too.
but
Yeah.
the ideas that were there were really good, you
Right.
know.
Right.
And so I'd read the book, and I was living in Mexico at the time, and I was getting a magazine or a newspaper or something from um, SEI, Solar Energy Institute in Colorado.
Mm-hmm.
And I got an electronic newsletter or something from him, and I'm looking at it, and I saw this little tiny article, and it said Gaviotas at the top. And I went, Gaviotas? What about Gaviotas?
Mm.
And they said, we're opening it up for the second time in our history to the public.
Mm.
And if you want to go, we're limiting the number of people. And I was like, gotta go. And um, and I was working with a woman from Colombia at the time, and that was very convenient. We stayed at her parents' house in Bogota, and she went with me, and so we had no translation difficulties, and um, and then we flew in to Gaviotas on a Colombian Air Force paratrooper plane and landed on a dirt runway that they have there because they didn't want us to drive out there because of FARC, the revolutionaries.
Mm. Yeah.
But on the plane, Paulo Lagarde, this guy right here, was on the plane, and he was telling us about it and stuff. And he said, "Now, when we get there, I'm a nobody. I mean, I'm just like anybody else. We don't have any hierarchy, no hierarchy,
Mm.
no generals, no privates, no sergeants, no nothing." And he said, "We don't have any police because we only have one rule." And what's the rule? The one rule is do what you can. Nobody has assignments, that they have to meet a deadline. Do what you can. And everybody works,
Mm.
you know? Or if you get sick and can't work, you don't work.
Mm-hmm.
Do what you can. It's a magical place. Magical. As we were leaving, I asked him, I said, "Are you still building all the buildings out of earth blocks?" And he said, "Of course." And I said, "Where's your plant?" He said, "Well, here, come around the corner." And there were two guys there pulling the pulling the lever on a cinder ram. I said, "How many blocks do you get?" And he said, "About 400 a day." I said, "I get 400 an hour." He said, "Yeah, but we don't use any fuel." And yeah, it was amazing. It was just amazing.
Wow.
So I wanted to include it here just because it's such
Great.
an amazing place. And it's a demonstration of, I know it's what you're doing also. I mean, regenerative design. I mean, it's you can do this. This is possible,
Right.
you know? It's just it's the corporate America that we're fighting.
And
Um,
so, Jim, if anybody watching this would like to go there, is there any way to go visit it, or is
well, I don't know, but they do have kind of a corporate headquarters building in Bogota.
okay.
So you can go there. I mean, you could get a hold of them for
Right,
sure,
right,
and then you can ask them if they're opening it up at any time,
right.
and you could try to get there.
To go visit.
Um, we were fortunate. I was real fortunate with Paulo Lagarde because we got there, and I thought it was going to be a madhouse to get a ticket, you know, and they were closing it to 20 people max,
Mm.
and so I was frantic, to get these two tickets for myself and the Colombiana,
Hmm.
and we tried it. I paid for them from Mexico with pesos, and because of the drug trade, they wouldn't take pesos, so it got rejected, and then we had to. I think Nora, she's not here, but I think she helped me. You were in Colorado, right? Didn't you help us get the tickets for Gaviotas? Yeah, she was in Santa Barbara at the time, and she managed to, do the banking for us to get the tickets for to go to Bogota. And then we got there, And I thought, well, it's going to be 20 people maximum. This thing's going to sell. There were only 14 of us. Only
Huh.
14 of us went. It was unbelievable.
Hmm.
Unbelievable. But I asked Paulo Ligari. Oh, and then what I was going to say is that we got there, and then Paulo Ligari was asking everybody that came, why are you here? What do you do and stuff. And I mentioned that I was working in Haiti,
Hmm.
and I was suddenly teacher's pet, you know. And he
Hmm.
said, and I was in his office at the last day, and he gave me this photo album
Hmm.
that had pictures, like old time pictures of when they were building the place, of the farming. They invented a seed planting machine. That's how they planted 25 acres of trees. And he had all these pictures. And I was looking at it and was, God, this is great. I said, why don't you, why doesn't anybody know about this? Why are you like a secret?
Hmm.
And he said, it's because um, we don't want to spend any of our time on marketing. We want to
Hmm.
spend all of our time doing. And then he gave me the book and he said, here, you tell him. I've still got the book. It's amazing.
Maybe we could make another video just for that.
Yeah. Yeah. Right. It's incredible. Anyway, I got
Mhm.
carried away on that, but I always do because it's a
There's so many stories. Yeah.
incredible story. Yeah. Satpram, this is in Barachara, Colombia. That's where we met at a workshop in Colombia. And that's his machine, his arm press. This picture was taken in South Africa. I'm I've crossed paths with Sapram in 4 different countries, and and then he spent some time living at my house in Mexico. So we're pretty good friends. That's why I get pictures from him every day of his dome, you know.
Mm.
But he's quite the character, and that's his arm press. Well, that arm press belongs to Alan Kuchek in Joshua Tree.
Mm.
And that picture's in Joshua Tree. And that's how I ended up going. Alan took a workshop from me in Mexico in 2006. And he called me like 16 years later or something. And I don't know if you remember me. And I said, well, I've done a lot of workshops. So I did. Yeah, so I didn't really remember Alan because I've done a lot of workshops and I've had hundreds of students really. But he said, well, it was Baja in 2006, and now I've got my land and I want my earth block house. And I said, that's hard, but you're going to need a California architect and a California engineer to have any chance of getting a permit. And I know those guys from the Earth Builders Guild. And Ben Loescher is an architect in Los Angeles, and Anthony Dente is an engineer in Berkeley. And both of these guys are earth friendly. So here, get a hold of them. And I introduced them to each other and they got it done. I mean, they drew his house and engineered it and got it permitted. And so we think it might be the first permitted earth block house in California. So I figured, well, that's it. We broke the earth ceiling. You know, California is the fourth or fifth largest economy in the world. We need to get going there.
Mhm.
And then the fire happened. And, it's just been a cosmic roll. So here we come, with earth block machines. And I inadvertently met these hemp guys and they jumped in. And then Alan met Ruben, the contractor. Ruben was like looking for a puppy or something. I don't know. And they met each other and it's just been, unbelievable. Unbelievable. And then, like I told you, Francesco called me the day the fire started. What are we going to do? So I want him in Los Angeles real badly, just
It-
because
Sorry.
yeah, he's built 50,000 earth block houses. I mean, he knows how to do this at scale, you know. So that's the goal right now. So anyway, here we're going back to machinery. There's orm presses at work. The upper picture is in Zambia. The lower picture is in Haiti. This is Lawrence Jetter, the original owner of AECT, Advanced Earth and Construction Technology in San Antonio. And that's one of his, they're called impacts. It's the smallest machine that belongs to me, but it's on my land in Mexico. Uh, and that's Lawrence. I remember in the laboratory, I said that little machine that makes little mini blocks.
Mm.
That's what he's pumping right here. He's making mini blocks. And then this is Ryan Runge. He's now the owner of AACT. He bought it from Lawrence. He lives in Colorado Springs, and that's my machine again, except that's in my backyard in Texas. And I've sold those already. I don't have them anymore. That's my original big AECT machine at 3,500. That one makes like 360 10 by 14 blocks per hour. It's uh, it's a monster. This is the one that built all the stuff in Austin too. Same machine.
And just to know, because you've got the machinery also to potentially mix it. How what because like so you got the machine that can create a lot of the bricks, but how do you make all of this mix so quickly? What's the technique there?
Exactly, exactly. A good and obvious question that I hadn't answered. And so I built without a mixer. I just got pretty well screened soil from quarries or something, and I wasn't stabilizing.
Mm,
So I was just making earth blocks. But as I told you, I suffered a lot of water damage in Colorado in the first couple
mm,
of years. And I said to myself, self, we need to stabilize these blocks. And so I sort of designed a mixer. I knew what it needed to do. You know, it needed to mix soil with a stabilizer, and then it needed to mix it with the water, and then it needed to put on a delivery system that would get it to the machine. And so I sort of designed a cursory design. And then I went to a machinist that I knew in Bayfield, which is between my home in Pagosa and Durango in Colorado, and talked him into building it. And we built it. And that was my mixer. And I used it successfully. That was in 1997. And I used it, I sold it last year.
mm,
So I used it continuously for that time. In the meantime, Lawrence Jetter delivered a machine to me in Colorado when I had just built the mixer, and he delivered the block machine to my construction site. I was using a different block machine that I didn't like as much, and I'd purchased one of this one, Lawrence's
mm.
3,500, and he was delivering this machine to my site, which was that castle that you saw,
Oh,
the one with
okay.
the turret and all that stuff.
Yeah.
That's the house I was working on when he delivered. I built the bottom story with the old machine and the second story with this machine.
Mm.
But he delivered the machine, and I already had the mixer, and he saw it. And he's a machinist, he's a designer, you know. And he walked around that thing, and he said, "What do you got here, Jim?" He's a Texan, a real Texan. And I said, "Well,
Thanks, Rex.
I needed a mixer, Lawrence. You can't do this with shovels, you know." And so I had this designed and built, and it's working. And he walked around it, and he walked around it, and he walked around it, and he looked at the auger and the hoppers and the measuring devices, and he looked at me, and he said, "I never saw a good idea I couldn't steal." And and he went back to San Antonio and started building mixers. He's got a pretty nice line of mixers now.
That he's
And
made.
there's
Okay.
littler mixers that you can get. I bought a little one here in Texas, and I'm bringing it to California. It's an Eimer. You
Okay.
may have, it's a pan mixer, and it'll keep up with the little red machine. It might keep up with the ETOL. It couldn't keep up with that machine, that blue one.
Mm, mm.
But we used it in Austin for the red machine and to make little 4 by 12 cunyas. But I got it, and I'm bringing that. and we'll see what happens. Um, Once we get some money, we'll buy more equipment, or maybe your welder is going to build us something.
There we go.
Um, I just got to get what I got there, and I just got to go for it. You know, that's what's got to happen.
Hmm.
Okay, so now we're at Ital Mexicana. That's Francesco Piazzesi standing beside one of his machines that I owned in Mexico. This is on my land outside of San Miguel. And I met Francesco a long time ago, maybe 96, something like that. Because I'd already gone in the earth block business. I'd already built earth block one and was looking for machinery. And I had found out that Ital Mexicana made machinery. So I took a trip to Mexico and I met Francesco. It was a bad thing about that trip. My suitcase got stolen. I was standing there at the luggage carousel in Mexico City, and everybody picked up their bag and left. And I was standing there looking at this thing going around with nothing on it. And so I was in Mexico City with nothing, the clothes on my back, literally. But uh, but it was a good trip. Francesco took care of me, and and we really liked each other, and we've been friends ever since. And then I had a machine of his in Mexico, and and now I have two of his machines. And he gave me, as I told you, he gave me a machine for Haiti.
Hmm.
And he's just a wonderful guy, and he's the founder of HLA Atukasa, you know, and he was nominated for the World Habitat Awards a few years ago. He didn't win, but he should have. Anyway, that's Francesco and an Ital.
And you said
That's the Ital he
they've
gave
built
us.
over 50,000 homes for people. Yeah.
Correct. And
Hmm.
it's all people that need them.
Hmm.
No castles for rich people.
Right.
So we need him in Los Angeles.
Hmm.
Um, this is the machine that he gave us for Haiti. That's me training the crew in Haiti how to make blocks. Um, Obviously, I'd just been working at Oklahoma. Got my OU hat on. That's in front of my front door in San Miguel de Allende. And the guy on the right, as you're looking at the picture, is Francesco, and then me. And the guy on the left is Bernard Amadei. He was the dean of engineering at the Mortensen School of Engineering at the University of Colorado. But more importantly, he's the founder of Engineers Without Borders.
Mm.
And we've been friends for quite a while too. And he hired me to go to Montana and make blocks for the Crow Indians. That's another whole story that I could launch into, but maybe I'll tell you some other time. But Bernard's a really good guy too, and now he's retired from CU, but he's still working on engineering. Engineers Without Borders has done stuff all over the world,
Hmm.
and he's the founder, and he's doing it. He's been in Uganda recently, and mostly it's water systems is what they do because they're all engineers. He's a Frenchman,
Mm.
um, and he speaks with a real heavy French accent, but he's a hell of a guy, a really good guy. Um, so this is the start of HLA Atukasa, and that's an HLA house in Mexico. Um, this is I didn't want people reading while I'm talking, so as you can tell, I don't have much reading material on my PowerPoint. That's on purpose. But this is just one of 100 pages about HLA Atukasa
Mm.
and just about their objective, and their objective is to house people that need houses, and they've been extremely successful. 50,000 and counting. It's an amazing organization. That's HLA at work. He's got a lot of his crews are from people that built the houses. They'd help build a house, and then the HLA guys would say, "Oh, that guy's a good plumber. That guy's a good mason. That guy's good at concrete roofs." And they'd say, "Hey, do you want a job?" And so
Mm.
they'd get a house and a job. And then he's got all these crews and they go all over Mexico building houses. And they're crews of people that got houses. I mean, it's this incredible sustainability circle, you
Hmm.
know. I think there's 32 states in Mexico and they've built in 29.
Wow.
So it just brings tears to my eyes to talk about it.
Mm,
Can't we do this in the United States? Really?
right.
That's them at work again. There's a development almost finished.
Mm.
Same deal. There's one finished.
And Jim,
That's me
how,
visiting one of his. Pardon?
sorry, how does he get the financing for these projects? You said that it was families
It,
that did it.
it, it he's incredible. I don't know everywhere he gets it. He did get a bunch once he has established himself and it was clearly he was successful.
Uh-huh.
He got funding from Infonavit. Infonavit is like it's the federal government housing association, you know?
Mm.
And so they were massively building concrete hot boxes that nobody wanted to live in for the homeless in Mexico. And then when Francesco had demonstrated that, hey, look what we've got and we can do this, he started getting funding from them. Not total funding, but got funding from them. The other place he got funding from funders, you know, but he also got funding. He told me about, I went to one of his projects. I can't remember which state it was in, but it was a big sugar factory. Okay. I mean, huge, huge sugar factory, hundreds and hundreds of workers. And so he went to the owners of the sugar factory and he said, do you have difficulty maintaining your labor force? And they said, yeah, we sure do. You know, they come and they go. We don't pay them a lot. We have to, we're retraining all the time, all the time. And Francesco said, if they had houses, they wouldn't leave.
Mm.
This is going to be real good for your business if you didn't have to retrain crews every day, you know? And they were like, you're right. And so they funded big bucks and he built housing for all the workers at the sugar factory and they never left.
Mm.
So that worked. And so that sales pitch worked for factories, who don't pay their workers very much and they have a big turnover. And so here's how to keep your workers, you
Mm.
know. And so that was one. That's not how he did it, but that's part of how he did it, you know. Here's Alan wrote this up. It's our little opening salvo into Southern California. And notice the bottom line: we have already been permitted in Southern California, and it's true. It's San Bernardino County. It's not LA County, but it's right next door, you know, and it's right between two faults. Alan's got faults on both sides of it. But and Anthony Dente, the engineer that has engineered these things, instead of that mass of rebar that you saw in Haiti, he's doing the same thing that Fred Webster did when he did the wineries 40 years ago. And they're using threaded rod, okay? And the threaded rod is buried into the foundation and attached to the rebar in the foundation. And then it goes all the way up and it goes through either through the holy blocks or through a cavity between two courses of blocks. Okay. I mean, there's different ways to build these walls, and that's another whole discussion. But anyway, it gets his way vertically and it goes through the bond beam, not to the bond beam, through it. And so the top of the threaded rod is above the top of the bond beam. And they put a big washer on it and a big nut, and then they cinch it together. They're putting the whole brick wall, under tension
Mm.
with threaded rod. And the threaded rod, I asked Alan how frequently it was happening in his house, and he said every 20 inches. So that's a lot of threaded rod,
Mhm.
but that's how they're doing it. Okay.
Yeah. No, thanks for that information. That's great to know. I mean, that's how they were able to get it permitted, I guess.
Yes, exactly.
Like
That's how they got
over-engineered.
permitted.
Hmm.
So this is more, about us, about the build with Earth. We're forming a corporation, Benefit Corp, of course. Um, and that's Alan's good at this stuff, you know. He's got a full-time job, plus he's building his house, plus he's doing all the paperwork for the formation of Build with Earth. So he's quite the dynamic guy. I don't,
Hmm.
have you talked to him?
Just a quick chat by
Yeah,
phone. But yeah,
yeah,
great guy.
yeah,
Yeah.
yeah. Okay, and then I think the last slide, there's Ben.
Hmm.
This guy, I'm giving him the last slide because he deserves an enormous shout out for what we're doing. Um, just, getting earth and construction codified with the IBC and the UBC. This isn't just local, you know. I mean, fortunately, he's a Los Angeles architect, but he's working the codes nationally and internationally for earth and construction. And he's running a full-time business, and he's how I met you
Yeah.
because he and Sasha were doing that big talk, and we were two of 150 people or whatever it
Right.
was. It was
Right.
on there, and then I put that little line in the chat bar, and you wrote, "I'm interested,"
Right.
and that's why we're here today. It's Ben.
Yeah. So thank you, Ben.
Thank you, Ben. Okay, that's it. I was telling Nora, I think I can do this. I did one for Austin, and I had 116 slides, and I did it in 47 minutes. So I said, well, I got 130 slides here. I can still do it in just over an hour. But we've been on here for three.
I think it's my fault too, because I had so many questions. It's you're just giving us so much amazing information, and I really
Well, it
appreciate
turned
it.
out to not be just an 80-minute presentation for your class. It was you and I having a conversation.
That's it
That's what
too.
happened. I'm going
Yeah.
to blame all this length on you.
There you go. There you go. I'll take it. I'll take it because I really enjoyed it.
Okay, great. Well, I did too. And I'm hoping that we're going to do a lot of work together.
Me too, Jim. For
I
sure.
really am. I looked at your Casa Atlas. What a beautiful concept plan. Except, I'd like those houses to be earth blocks.
Well, that's it. I think you're the person who's making me change my mind. Like the original idea was to use light straw clay because I
Uh-huh.
felt it was going to be easier to get it permitted. But now that you guys have actually managed to permit the stabilized earth blocks, I think it's actually the way to go. So
Yeah.
just know that.
Yeah. Okay. Well, and not to knock straw. I mean, it's better than sticks, but it has some failings that we don't have, quite frankly.
Mm,
Um, I know they say it doesn't burn, but I've got a picture of a straw bale house I mean, the only thing standing is the brick chimney.
yeah,
It did burn to the ground. It was in Durango.
right.
Um, so they can burn.
Yeah.
Um, my wife is a psychologist when we were living in Colorado. She was working at a clinic in Durango with another woman who was a psychologist also. And that woman and her husband bought a straw bale house. They didn't have it built. It had already
Mm,
been built and lived in, and they bought it from somebody else. And they wanted to put an addition on it. And so they were putting the foundation in for the addition, and they realized that we need a door coming out of the current house into the addition. So they took their chainsaws and they cut a doorway in the straw bale, and it was a labyrinth of rodents and rodent poop and rodent skeletons and rodents.
mm,
Once a rodent can get through a hole the size of a dime,
mm,
and so if you got a hole in your plaster the size
right.
of a dime, they like it in there. It's real
Yeah.
comfy, easy to dig and crawl and
Yeah.
nest and woohoo. So that was another drawback. And then I saw
Mhm.
something the other day about, you know, I think it was maybe in your uh, Atlas presentation, the woman was
Mm.
talking about, you know, uh, water being an enemy.
Hmm.
And I bet it is, They get wet, isn't that going to get moldy? Or, I mean, how's that going to dry out? Or, I don't know, but we're impervious to water.
Right. Yeah. Yeah.
And,
No, you're
if
right.
a,
There's many advantages, and that's why I really feel like your presentation, especially, like students of architecture, engineers, people who are even thinking of, doing urban planning and the rest of it. There's so many students that are part of this class. And I think for
yeah,
them
I
to
know.
really learn about this technique has so much potential. So I'm so glad that you're able to share that with them.
That's right. Okay, good. Yeah, I like to get to the students too, especially the architects and engineers.
Yeah. And
We
I
need
mean,
them on our side.
I just want to say this to the students too, like how motivated you were. You were even going to travel to come to Cal Poly to give the presentation in person and everything else. And I know you've put so much effort, and Nora as well, in this presentation. So, um,
Yeah, Nora gets a big shout out. Here she
yeah,
is.
big shout out for sure.
We're not taping anything anymore, Nora. So come and meet Rohan here. Here's my
Hi.
There we go. We can see you.
You're
Yes,
the one
thank
who
you.
deserves an enormous credit because you hung in there for a long time.
yeah.
It was my
We did it.
pleasure. It was
We
my
did it
pleasure.
over like 4 times,
Oh,
because
well,
I'm not
we're
electronically inclined.
we're better at it now. But
Exactly. You're
we're
now
just so glad
experts.
to know you and be connected with you, Rohan. It's fantastic. Real
Such a
exciting.
pleasure too. Thank you so
You're
much. Yeah.
doing so
And
many wonderful things.
thank
Yeah.
you. And I
Okay.
look forward to meeting you both in person soon.
Yeah.
Yes, we are
Yeah.
too.
Yeah.
We are
Thank
We are
you.
too. And I hope you hook up with Ben pretty soon.
Definitely. Yeah,
He'll be your friend for sure. He's a good man.
that'll be great.
And he owns the Red Dog Saloon in Pioneer Town.
Did you mention David?
Oh,
You do
wow.
growing stuff?
What's that, Rowan?
No, 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 no. That's great to know. I was writing to him and he was like, we can meet for a coffee or a beer. And so I'm just thinking of the saloon now. I can imagine
Yeah.
it there.
Did Jim mention that was a Hollywood movie set, that little town?
Oh, wow. I
Yeah.
love that
Pioneer
place.
Town was built so that Hollywood could shoot Westerns.
I see.
And now I guess, I haven't seen it, but I guess it's a real town. People live there.
Uh-huh.
And Ben is part owner of the Red Dog Saloon in
That's
Pioneer Town.
amazing. That
Did you
that's the main
mention David?
restaurant, right?
Yeah,
Maybe
David?
Yeah.
Hansberger?
Yeah, and
Yeah.
anything with growing.
Yeah. Well, yeah. And also I have a nephew. Um, he lives in Hawaii right now. He got his PhD in entomology. He's a bug guy.
Uh-huh.
And but since he was in high school and through college, he'd always worked with me on earth block buildings during the summer. And he's like a son to me, really. His, yeah, he really is. So,
He's still interested in earthbugs, but in entomology, he does a lot of organic biocontrol of pests. And
Mm.
so I don't know if your sustainable efforts ever veer into that realm, but he's
yeah, well,
very
bugs are a real big part of regenerative design,
mhm.
Oh, absolutely. Yeah. Yeah, especially with the landscaping side and the agricultural side for sure. So I'm very interested. Maybe we could organize a talk or something. But I'll,
Yeah,
I'll let I'll let the students go and we can continue speaking because I think we could carry on for hours.
Yeah,
But
this is the start of a long friendship.
yeah.
exactly. I feel
But
that
your
Very,
too.
students, are your students in intact today? They're not looking at this, right?
yeah.
No, that I'm going to be sharing this with them.
After you cut it by an hour or two.
Yeah, it's gonna be hard. I just want to share the whole thing. So let me just finish it there for them, finish the recording. So just thank you so much. Really
Okay,
appreciate it.
thank you.
All right.
Um, and I'll get the finished product.
Yes, yes, I can send it to you too. Yeah, absolutely. And actually, you know what? If someone wants to contact you, how could they contact you?
Oh,
Watching the video.
that's the last slide, I think.
Oh, there we
No.
go.
It
Oh
is.
no.
Yeah, here it
You
is.
don't have it there?
Last one.
Well, it didn't get there. Look,
Oh,
I can't get there.
how odd. Click on next slide here.
Oh, there it
Ah,
is.
there we go. Perfect.
Where I don't
There
know
you
where it
go.
went.
Here at the beginning, slide down to the end.
It's there, right?
Yeah, well,
Jim at Earth
I
Block
saw it flash
International.
by, but I don't know why we didn't get to it when I was thumbing through the.
It's fine. It did appear. So people will
It
have
did.
seen it. Yeah, there you go. If you want to go back there.
There it
There
is.
you go.
There it is.
Yeah,
Yeah, but
excellent.
there's Ben, and then when we got to Ben, I hit the key. Oh, it did go. Okay.
You
There's
are
how to get.
experts. You're officially an expert.
Yeah,
All right, I'll finish it here. So just if anybody wants to contact you, here's your information. Yeah.
I understand that you're going to need to cut whatever you want.
I don't want to cut anything. I thought it was great, but
Yeah.
thanks so much again. Thank you. Thank
Yeah,
you.
you'll
Thank
have to
you.
give them. You'll have to do a 2-day class with coffee breaks here.
I think your participation made it so much better though, Roland.
Yeah, it was
You had
fun.
great
Oh,
conversations, the two of you.
He wants to go.
appreciate it. It was really
Bye,
great.
Rowan.
Enjoyed it. All
Thank
right.
you. Thank you so
Bye-bye.
much. Bye
Bye-bye.
bye.